to our Honorable Director Madam, dignified speakers, staff and faculties of IIM Sirmaur and our participants across India. We are happy to see that around more than 100 participants have registered for this seminar. IIM Sirmaur is a centrally funded institution of national importance set up by the Government of India in 2015. IIM Sirmaur, which is based in Sirmaur district, Himachal Pradesh, is one of the newer institute in the prestigious IIM family. Our institute currently based on its temporary campus at Ponta Sahib, and building work at our permanent campus Dholakua has started in full phase. The institute has registered for Unnat Bharat Abhiyan in 2019 and actively working for it. As part of UB, our institute in consultation with local administration of district Sirmaur has adopted 5 neighboring villages, Kunja, Jamniwala, Ajoli, Danda and Dobri. The institute aspires for the seamless integration of management education with local and global aspiration in an enabling environment. It believes that management education is not just about seeking the most competitive employment opportunities, but also about learning to serve socio-economic concerns through ethical and visionary corporate leadership. With the team of enthusiastic faculty members, staff and students, apart from academics, the institute is focusing on waste management, community engagement and outreach activities, and trying to differentiate itself from other management institutes. Our theme is water, air pollution, solid waste management and issues to the environment, and how we can treat it in sustainable way so that we can mitigate the climate change and also conserve the natural resources. Today we have our dignified director IIM Sirmaur with us. Professor Nilu Rometra, founder director of IIM Sirmaur, she brings to table combined experience of over 30 years in teaching, research and administration. Professor Rometra is a US State Department IVLP alumnus, Fulbright Fellow, and has been postdoctoral Commonwealth Fellow at Lancaster University, UK. She specializes in the area of human resource development, organizational behavior, and cross-cultural management. Professor Rometra's contribution to higher education have been recognized with various honors and awards during her esteemed career. But it is pertinent to mention that she has been honored the First Lady's Award for being the first woman to head an IIM by Ministry of Women and Child Development, Government of India. Currently, she is on the boards and committees of different various academic and administrative forums at national and international levels. As founder director of institute, the institute has grown under her able leadership from the first batch of 22 students in 2015 to approximately 340 students in the current academic year. From one flagship program to start off with, IIM Sirmaur has introduced 2 new programs, the MBA Tourism and Hospitality Management and PhD program in Management during her tenure. The construction work for the permanent campus at Dholakua is going on in full pace under her able guidance. Further establishing the Center for Sustainability and Environmental Management at IIM Sirmaur has been her vision and crucial step to fulfill the objective of community engagement as well as working for social and environmental cause. Without wasting more time, I would like to request our director, ma'am, to address the online gathering. It's over to you, ma'am.
Thank you, Dr. Ghosh. And thank you for the kind words of introduction that you, though it was very elaborate and not required, as I always say, but as a maybe tradition, you always make it a point to introduce me to the new set of speakers that you host in your seminar. So thank you for your such a vast kind of an introduction, which I think is not required at a forum like this, wherein you have invited so many experts from the area of waste management and water management, which of course I am no one to actually, no way I can claim that I have any expertise in that area. Anyway, thank you for your kind words. And thank you again for asking me to kind of say a few words on the occasion when we have all joined together to uh, celebrate this important day of as you told me that it's a sustainability day. It's a that we are going to celebrate across. So in the first place and at the very outset, I would like to thank our speakers who have agreed to kind of come over for the seminar uh, and have agreed to share their words of wisdom with the participants of this seminar. And I'm also happy to understand that you just said that we have about 100 people, 100 persons registered. Although the figure of participants currently on the document that is just in front of me on screen, it's just showing that only 30 people have got connected right now. So though there are 100 people registered, but this figure is just showing that only 30 people have connected for the first inaugural session. So therefore, maybe they will join in while the sessions progress. Nevertheless, as I said, I'm not an expert in the area, but the Center for Sustainability and Environment Management, which we have launched as one of the major initiatives with the approval of the Board of Governors. I can actually say that this is one of those occasions and one of those initiatives by virtue of which we are going to make larger difference in the life of the community around. Uh, Dr. Ghosh has been very prominently organizing various kind of activities under the banner of the center, and very actively she has been extremely successful in bringing across numerous acknowledged experts in the area. So today, yeah, the details of speakers that I have in front of me, if I go by the kind of a schedule that has been supplied to me, we have the speaker today, Dr. Kumar from Department of Civil Engineering, IIT Madras. We also have Professor Shiva Prasad from Department of Civil Engineering. Again, this is Govind Vallabh Pant University of Agriculture and Technology. We are going to be joined by Mr. Jayant Joshi, who is Group General Manager and Head Engineers India Limited, Professor Anurag Garg, Environment Science and Engineering Department, IIT Bombay, Dr. Sumedha from Department of Civil Engineering, IIT Delhi, Sonia Garga, who is Director Strategic Partnership and Programs at Sahas. Then Dr. Brijesh Kumar Dubey, who is from Civil Engineering, IIT Kharagpur, PK Sinha Center for Bioenergy and Renewables. So this is extremely encouraging for us as an institution, wherein we are able to extend our arms and have our association with the various institutions like IITs and other institutions, universities here, and the experts are collaborating with us over these kind of seminars. So I can see in this session that Professor Shiva Prasad is kindly connected. So thank you, sir, for joining us and coming over for this session, and you will be delivering your talk to the participants. Again, I can see connected Dr. Kumar is also joined for the session. So thank you, Dr. Kumar, again for agreeing to our request of the center and joining us here. Thank you very much. And I can also see Dr. Sonia Garga's the block on the screen. So thank you for joining for this session as well. Although I can say that the kind of interaction that this platform will actually extend as an opportunity to the participants, the kind of inputs that you people as experts will be sharing with the participants, I'm sure all those who are interested in the area, they are going to be benefited by it. But at the same time, let me put it this way, that the issues in environment and issues related to sustainability are also a matter of generalization, I would say, because they pertain to us for everyday life, that we live not just as experts but also as just normal human beings, or for that matter any living being on this planet is affected by this domain. I mean, our responsible behavior as human beings towards our environment can actually trickle down to and get multiplied into various kinds of sustainable growth that we are looking forward to in this environment. Uh, as an individual or as a person, when somebody appreciates and wants to go on the hills in the Himalayas or elsewhere, we look for the natural beauty. But I'm sure this natural beauty can only be sustained. This will be only natural if we are conscious about our responsibility as people, how to sustain these kind of natural resources. Same is the case with the animal kingdom. For example, if we love animals, we have to be careful about our own behavior as human beings as to how that animal kingdom is protected. So I think when we talk about sustainability issues, when we talk about environmental issues, when we talk about responsible behaviors, the ball rolls down to the fact that how as persons and individuals we are actually looking at ourselves and monitoring our own personal behavior in terms of sanitization, you may say, the waste management, the water resource management, and so on and so forth. We are, when we open any columns of the newspapers, we come across a lot of natural calamities these days. We are coming across the occasions when we are saying that there are a lot of landslides happening, or we are coming across situations where untimely incessant rains are happening, which have given rise to a lot of landslides. I think it has something to do with our irresponsible behavior as people, wherein we have become so selfish with our own kind of understanding about our own kind of entertainment, call it through the tourism, call it through whatever ways, that we are not bothered and concerned about our own behavior towards environment, which is actually paying us back in a very very dreadful manner, I would say. So we do need development. For example, in the mountains and the Himalayas, we do need connectivities. We do need, good produce in our farms. We do need good roads. We do need everything. But I think the basic expectation from any scientist today, from any professional and expert today, would be to find out ways how this, balance between the development and sustainability can be arrived at. Because if this balance is ignored, I'm sure days are not far off when we walk on the roads, we will not be finding ourselves much safer, because we don't know what's happening as an impact. It's only the scientists who can predict, but as normal persons spending our day-to-day life here and there, we don't even bother to understand that what if there will be no water left, what if there will be no fresh air and there will be all pollution. We are not bothering about if there is all plastic waste around us, how we are going to, how it is going to impact the whole planet and things like that. So I personally feel it's a slow progression towards dreadful situations which may not be very sound for the humanity itself, or any living being on the planet itself. I think this is the high time, and it is very, very encouraging that Indian Institute of Management, Sirmaur, through its center, through its CSR activities, through its UBA programs, is able to at least think about, at least create some kind of platforms like these today, wherein we are spreading across a message to a small number at least, to create that awareness. And I'm sure this exercise over a period of time will make some fruitful results. So slowly and gradually, this awareness will reach to the ears and the sensations of the people who are listening to us today. As a management institution, I would actually advocate and profusely kind of want that the center and some select faculty associated with these kind of activities, I'm going to very shortly formulate a committee on the in the institution, which will come out with the typical multidisciplinary angle course in line with the national education policy to cater to these kind of issues. So I'm going to get along it a complete set of kind of a curriculum which will address to these issues from the scientific, from the resources, from the management angle. And we will certainly have, even if a bunch of the professionals coming out from IIMs who would be actually alert, vigilant about the resources, the natural resources, the environmental resources. And this is what is the ultimate vision we are going to go ahead with. To tell the audience who are connected here, we are in the process of formulating an advisory committee for the center as well. As I said, the center is doing a very fruitful job, although with the limited resources. And my congratulations to the coordinator, especially Dr. Arpita Ghosh. Right from day one, she is steering this exercise, and this year she's also joined by the co-coordinator, Dr. Parul Malik. And I'm sure in times to come, in next 1 or 2 years, this center will have its own place in the overall environmental management or sustainability issues. They will have a place. They're also undertaking a lot of research projects, and wherein the other faculty in the institution, like Professor Amarinder, Dr. Devika, Dr. Rinki Deya, they are also involved. At least in 2 projects, I am myself, collaborating and working with the faculty together to work with the farmers on organic farming, or with the the one of the scholars is working on a case comparative study of Indore and Himachal Pradesh, things like that. And I mean, a lot of work is happening with a small team at least, but I am sure they will make wonders. And with the support of the expertise that they are able to gather, my congratulations again to the center, that the kind of expertise they are able to gather from IIT setups and other universities. The day is not far off when this center will be in a position to float some kind of excellent programs to be offered to the corporate, to the students, and we will be able to join hands with IITs and some universities to offer joint degree programs as well. So not taking much of the time, because I did not have any inclination to speak so much today, but I thought, let me vindicate some of the plans for the center. Let me announce some of the things for the center. One of the major initiatives that I'm going to prompt some of the faculty through the committees that I'm going to formulate, that in next 1 year, we are able to launch at least one good interdisciplinary program, wherein we are able to join hands with the scientists who come and collaborate with the management experts in the IIM domain here with us, and we are able to showcase that yes, sustainability issues can be debated together, the resources can be managed, because it's a question of science. and management coming together now. As I have understood it, that we must have some scientists on board with us in management domain as well, because the amalgamation of the scientific tempo, the gelling well of the scientific tempo with the management tempo is going to make larger difference in the kind of policy possibly that we are looking for to look after environmental issues in this country at least. So I'm very ambitious about what is going to be the indigenous point of view in this as well. I'm very hopeful about what CSR we can do, but I'm extremely happy to announce it today that very shortly we are going to come up with a curriculum which actually exclusively takes care of sustainability, environmental management issues. Maybe as a small step, we do it in a smaller platform, in a smaller way, but in next 1 year, this is going to happen. So thank you very much, Dr. Arpita Ghosh, and my sincere gratitude to the team at the center, the faculty who are associated with the center, and many congratulations. The only word of wisdom I would also want to extend to the center people who are associated with the center, that don't get tired and don't get disturbed by the fact that you are a small team. Small can make wonders. Small is beautiful, and the founding people, they certainly have to make much more larger effort than those who will come after you in an established firm first. So you are the history creators. The people who are working today at IIM Sirmaur, they are the founding people, they are history creators, and they are setting the benchmarks on the basis of which the coming generations are going to remember the contributions of all those who are working today, because Union Institute of Management Sirmaur itself is just a young institution established in 2015. And any expert, I would go to the extent of saying that any expert who joins us as a professional and speaks to our participants or people, they are the members of our extended family. They are part of the extended family of the center, whom Dr. Ghosh should be happy to kind of connect to. And tomorrow when we are working on the specialized curriculum in this perspective, where I'm looking for the wisdom of the scientists to come in terms of what kind of courses to be offered in that complete program, I'm sure everybody will come forward to help the center and Indian Institute of Management Sirmaur to be able to showcase that yes, some kind of amalgamation can actually take off and bring laurels to the institution. Thank you once again, and my congratulations and thank you to all the experts who today who have agreed to come forward and discuss on this platform. Thank you all, and as I always invite experts, so my humble invite to everybody who is joining us as experts today. The COVID has is little under control, so we can more often meet on face-to-face as well. So whenever Arpita organizes a physical seminar, so Arpita should invite all of you to Indian Institute of Management Sirmaur at Ponta Sahib, and please come over and travel and talk to our students as well, or all those who are interested in this domain. So thank you all. Thank you very much, and for giving me an opportunity to share my, thoughts, my views, and I'm happy I was part of this seminar today. Thank you, Arpita. Thank you very much. Thank you, Parul. Thank you very much.
Thanks a lot. Thanks a lot, our director, ma'am. We are fortunate enough to have you as director and with your ambitious plan and vision. And nice to know your future plan as well. We are very grateful to have you.
Yeah, so it is a surprise to you people also. So I never vindicated to you, but I just thought that today's the sustainability day, the world globe is celebrating this day. So let me make this announcement that Indian Institute of Management, it should become a headline that Indian Institute of Management Sirmaur, this should become a headline, that Indian Institute of Management Sirmaur will shortly offer, a dedicated course wherein we will collaborate with the scientists in the country, with the IITs within the state and outside Himachal Pradesh as well. And I'm sure we are going to make a larger difference in this. Please make it a headline for today.
Yes.
Yes.
Thanks a lot, ma'am. Thanks a lot. Thanks a lot to our director, ma'am, for her speech. Now, without wasting time, as time is very limited for other speakers as well, so we are moving to Professor Madhava. So Dr. Madhavi is an associate professor in the Department of Civil Engineering, IIT Madras. He obtained his bachelor's and master's in engineering from Government College of Technology affiliated to Bharatiya University and received PhD from IIT Madras. He worked as postdoctoral researcher at National Chao Tong University Institute, Taiwan for 4 years and worked as an assistant professor at NIT Calicut for nearly 4 years and then joined IIT Madras. Dr. Madhava Kumar's research interests include water, wastewater treatment using membranes reactor, emerging pollutants, removal by advanced oxidation process, trace organics, and nutrients removal for reuse materials from solid waste. So it's over to you, sir. As time is limited, your time is only up to 11:45 as you have class. So yeah, it's over to you, sir. Thank you. Sir, sir, you are not audible. And we are also very grateful to have all the speakers here from, we have 7 speakers for this seminar and all speakers are from reputed research and academics, including IIT and also from industry as well. So we are very grateful to all the speakers and we are very lucky to have them.
Ma'am, is there any network issue? Because sir is not audible.
Professor Madhava,
So is this expert not connected? What happened?
sir,
Hello.
hello. Sir, are you able to share your screen?
Hello, can you hear me?
Yes,
Sir,
yes.
sir, we can hear you. Please continue with the audio only.
Hello. Yeah, okay.
Hello.
I'll close the. Yeah, yes, yes.
So please continue with audio only. Thank you.
Yeah, could you see the screen? And you can hear me as well?
Yes, yes, we can, sir. Please
Yeah,
start.
thank you very much for the opportunity. I thank the co-convener, Dr. Arpita Ghosh, and the co-convener, Dr. Parul Malik, and also the respected director of IIM. And happy Sustainability Day. And I put the title of today's lecture as the water quality pollution treatment as well as the sustainability practices. So as director rightly said, the water availability is very important for any organism to really flourish, right? And it should be available in unpolluted or the purest form. So obviously that is more important. We have to really take responsible for that. And if you list the sources of water which is really available, starting from groundwater, surface water, to we have the other sources like seawater, where you do not have enough groundwater and store water, water available in the surface. We can extract the water from there. And two other important aspects which I really wanted to highlight is the wastewater will be one of the resources for water. So the wastewater can really be continuous in supply, so we can really treat it and use it for our domestic requirements. Right, the country like Singapore is already practicing for the last 10 years, and we can also extract water from the air. So this is the water distribution. Even the small quantity of water which is available, that is not really in the purest form. And coming to the surface water and groundwater, which is really available, right? The hydrogeology, which is really important, because some of the parts of India, you have the problem of fluoride and arsenic, right? When the water is really digged from deeper into the ground, then obviously you have a geological strata which is having the arsenic and fluoride, which is really problematic. And the other side, if you really take the water as total dissolved solids. TDS is nothing but the total dissolved solids. If the level is less than 10,000 milligram per liter, we take that as really the pure water. So the ultimate aim is we are supposed to have a pure water there. And the ultimate use of water, final purpose, what purpose we are really using, it is for cooking or maybe like a bathing or gardening. That is really important in deciding a particular treatment option and selecting the source of the particular water here. And this is the water demand in India. So you have the various sectors, and you can note down here domestic wastewater will really, domestic requirement is really this much. Then obviously 80% of it is really coming out as a wastewater. And if you see the statistics about the availability of water, right? So from the Ministry of Jal Shakti, as per the 2020 statistics, the per capita water availability is 1,816 cubic meters, right? So that is the available per capita demand. So this is really gradually decreasing because of the population increase, and also not enough water which we have. Really, we overexploit the water, so it is really depleting it. On the other side, you have the liter per capita per day demand. The ministry has decided to supply for urban population 135 liters per capita per day, whereas it is for rural, it is only 55 liters per capita per day. And people are working that in every household there should be a house connection as per the Jal Shakti ministry, and they are going to really formulate and already formulated several schemes so that when you open the tap, you're supposed to get the water even in rural places, and the water should be of purest form. But if you take into a map, right, where you have the water available, right, and the water is sometimes available, but not at its purest form, right? So water scarcity can be divided into two. Then is physical water scarcity and as well as economic water scarcity. So physical water scarcity is really water stress we have, water is not available. Then obviously India is facing in major metropolitan cities like Chennai, Mumbai, Delhi and all, like stressed with water. Whereas in the other places where you have plenty of water, take an example of Australia, right? Like Sydney, Melbourne, other places, you have plenty of water resources, but the water is really contaminated with pollutants. So that time you need to have some budget to really treat the water pollutants. That we just call it as economic water scarcity. Water is available, but economically you need some budget to treat them. And if you see the historical events, right? Water treatment is new. It is not really new. 4000 BC, ancient Greek really treat the water but boiling. But even if you see the trend, 1500 BC, Egyptians did settling of solids, and many other things are really happening. Even the slow sand filters, what we use these days, is really established in 1829. The first drinking water supply is really done in 1902. So if you see the history, it is not really the new things, but things are formulated. We are really updating it so that we really maintain the sustainability in water treatment. That's what we really do. But the scenario is really changed when we have the passage of Safe Drinking Water Act in 1974 in USA. Then we follow the same model to establish our own standards that really introduced the awareness about the water pollution and the water contaminants. So the goal for 19th and 20th century is challenge to eliminate the waterborne diseases, whereas in the 21st century, it is mainly because of the man-made chemical removing and the microbial contamination, how to protect it, and also the viral contamination. Recent days, we have the pandemic COVID-19, right? And the other important focus is risk assessment methodologies to assess the health risk. And coming to water pollution, what are the predominant sources that really contribute to water pollution? So there are point sources, there are non-point sources, there are transboundary sources. So if a point sources is from a single source, like a water treatment facility, if you're untreated and really letting the water to do it, or an industry which is not treating the water and letting it go, all these things, even individual houses where we have the septic tanks, right? If the septic tank is not really designed or not properly constructed, it can also lead to microbial pollutant as well as the pollutant which is released from the feces and other matter. So this is a typical example of point sources. In the non-point sources, we have from the diffusive sources, right? We cannot identify or pinpoint one source, but we have the agricultural runoff, stormwater runoff, and all other debris which is really coming from the land to water are example of this. And coming to transboundary sources, for example, where we have allocation of water. For example, the water source is migrating from one country to other, right? So we'll deposit the contaminated water in one place where it really takes out to the down direction, and it can really lead to transboundary sources. So these are all the forces, and we adopt certain technologies to treat it at the source, and we really adopt some technologies to prevent the contamination to maintain the sustainability in the water environment. So coming to water quality parameters, right? We can divide them basically into physical parameter, chemical, and biological parameters. Chemical, the name itself says various chemicals, including the pesticides, metals, non-metals, and you were using the antibiotics or the pharmaceutical in the recent days, and you use the personal care products. All these things are really coming into the category of chemical constituents and produce some kind of a chemical parameter analysis. Physical, the physical sensation, right? What we really see, like a visual or sensation to our skin, or what you really smell, all these things really like temperature, turbidity, and other parameters are physical. And the biological, you have the presence of microorganisms, right? We all have the quality parameters. So there are water quality standards that will restrict the presence of contaminant in physical, chemical, as well as the biological classification. So what I'm trying to do is, when you really wanted to design a treatment plant or prevent the water environment, sample collection and analysis are the most important for determining the property, characteristics, and design of the particular systems. So when you really design it, as an engineer or the scientist, you really detailedly look into the what is the status of the pollutant, whether it is really suspended, right? If a suspended or dissolved, classification is really 0.45 micrometers. If it is really bigger than 0.45 micrometer, it can be settled by means of gravity. If it is not by 0.45 micrometer, you need to really bound them, aggregate them together, and we need to settle, or we need to adopt some other technologies. Other side, whether this compound can be volatilized, right? By upon degrading this, we can really convert it into carbon dioxide or any other form, or it will really present in the same form, or it can really not degrade. And the other side, you have the nature, like organic, right? If it is an organic, all essential living organisms need organics. So basically, if the pollutant is really biodegradable and organic in nature, or inorganic sometimes, based on the metabolic activity, the microorganism can utilize these compounds and degrade them and remove the contaminant. And if they are really reactive, right? For example, like you have a carbon, you have a nitrogen, both the things form sometimes the cyanide, CN, right? Sometimes it may also really happen. So we need to understand whether the possibility of reactive things can happen in the combination of pollutants. And overall, the water is really toxic or not. That is also really important. These days, people analyze for toxicity of the particular compounds. So if you list the compounds, right, for example, like pesticides, they may come into different categories. They are really dissolved, they are really organic, they are really non-biodegradable, they are really toxic. So we need to group them into different classifications and see which method is really appropriate for removing the type of pollutant. So if you see the conventional or a common pollutants, right, we have the organic matter, nitrogen and phosphorus, metal and other nutrients, you have a dissolved iron, we have the emerging pollutants. The emerging pollutants again can be classified into pharmaceutical, personal care products, then industrial additives, flame retardants or surfactants, right? And yes, as I said before, there are Indian standards specifically for groundwater sources and surface water sources, as well as we have the coastal systems. So all these are really highlighted in green color here. And other than that, we have the Water Prevention and Control of Pollution Act, and we have the Water and the Environmental Protection Act separately. You can really get all these things from MOEF website, Ministry of Environment and Forest website. As far as the drinking water is concerned, IS 10500 2012 is the code or the Bible which can really follow it for our Indian context. And coming to wastewater treatment, right? People misinterpret that like water treatment and wastewater treatment are really different. But if you look into carefully the scheme of wastewater treatment and water treatment, they are both share somewhere their origin. So for example, like wastewater treatment is really treated primary, secondary and tertiary. And if you look into the advanced oxidation scheme, it is look like a simple three-stage scheme. But whereas if you look into details, then your tertiary itself is really starting from here, nitrogen removal to reuse. That's the advanced wastewater treatment. Recent days, emerging pollutant and other compounds can be really removed using this advanced treatment scheme. So what is there in the tertiary treatment? We have the coagulation, flocculation, or the sand filters, or the membrane filtrations, or the carbon adsorption and advanced oxidation process. So if you really compare this tertiary treatment with respect to a common water treatment filters, right? For example, like emerging treatment, emerging contaminant removal is really by advanced oxidation, membrane technology and adsorption on the combination. And if you compare the filter, this is the one filter which I have in my house. If you see and compare the arrangement of the filter in the house and the tertiary treatment, it more always same. It follows a sediment filter, right? The same filtration here. And the carbon filter, you have the carbon adsorption using an activated carbon or any other material. Third one, you have the UV unit for the disinfection of the microorganism, biological pollutant, or oxidation of your very stable compounds. And you have the membrane technology improved. You have membrane technology of different types, but choosing a right technology for any treatment is the key for success. But again, before choosing a right technology, accurate sampling and analysis are the backbone for the success. And coming to sustainability, how do we really interrelate the concept of sustainability in water and wastewater? This is the basic schematic diagram of sustainability. You need to connect with people, planet, and profit. And the technology which you really develop supposed to be like a bearable and equitable, and it is really viable on a long run. Some of the history which I have shown there, even the filtration using the conventional sand filters or treatment using the ozonation or any other method still really surviving. That's the sustainability, because they don't really create much of a problem for the people. But again, if you really wanted to update the technology, you need to understand what is there in the basis. And this is a good definition which I really understood for connecting with water treatment. Sustainability, the exploitation of the resources and the direction of the investment, the orientation of the technological development and the institutional changes are all in harmony, and they should meet the human needs and aspirations for current as well as really the future. So in line with this, I'm really giving you some example. Dr. Arpita, you can stop me wherever the time is over, right? Okay, coming to sand filtration, right? This is the conventional sand filtration where we have slow sand and rapid sand filter. They are directly targeted to remove the dissolved solids, suspended solids, including the bacteria at times. But the 1970s, we moved on from the conventional filtration to membrane filtration. For example, like MF, microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. In the filter, which I shown you in my earlier picture, that is really typically a UF filter, which is available in the market. So why I really use the UF filter is my pollutant removal I want is only the bacteria and sometimes virus. This is enough. If you wanted to remove only like your TDS, then you need to go your reverse osmosis membrane. Sometimes people really use RO filtration to remove bacteria, right? So why I would say like you no need to go for an RO for bacteria is essentially here, if you really wanted to treat the water from microfiltration to RO, the energy required is 25 times higher per kilowatt hour of energy per meter cube of wastewater treated. And the quantity of water which is really going to come out is really 4 times lesser in your RO compared to your microfiltration membranes. So based on the characteristics and type of pollutant present in the water environment, please choose the membrane. Don't directly go there with an RO and remove all your nutrients, and it will create kind of a lag in nutrient in the water which you really undertake. And one simple thing in the membrane technologies, because we use membrane technology for our water and wastewater treatment, you can customize to any shape. That is the beauty of this particular technology here. And the membranes can be like a hollow fiber or flat sheet. We do prepare the hollow fibers as well as the flat sheet in our labs. And we really do the flat sheet because when you see it, it's a bound module. If you open it, there is a pattern through which the water will pass through. And you have above this particular pattern, you have the supporting layer. Above that, you have the flat sheet membranes, right? Now the market, people manufacture the flat sheet membrane modules, but sometimes when you closely look at, they have some kind of a small valleys, which is really accumulate all your fouling material. So what we try to do in the lab is we will make the surface very smooth by means of coating some nanoparticles. So for example, we prepare TI nanoparticles, graphene oxide nanoparticles, zinc oxide nanoparticles, even silver nanoparticles we prepare and we'll coat it on the particular surface here. So we use the polymerization techniques. We have a recipe and we have the different nanoparticles and different combinations we'll optimize. I'm not going into the details though, but if you observe a membrane which is prepared without a nanoparticle, this is the image, right? TFM image which we have. You can see here, there is a peak, there is a valley. This is the place where all your pesticide or personal air compounds will really get attached to it. Once they really attached, when the water is passing through the membrane, it will accumulate more and more particle and it will really tend to form. But this is really visualized by surface roughness coefficient 60.9 for a pristine nano membrane filter. But when you add the nanoparticle, this roughness coefficient is really coming down. And if you increase more and more particle on the surface, it is going to really improve. So there is a balance. What is the right percentage weight of the nanoparticle, which is supposed to be coated to increase your water flux through the membrane? So this is the ideal thing. So if no nanoparticle is really coated, you will get only 22.8 liter per meter square per hour of water through the membrane. But when you coat it, then this water which is coming out per meter square of the membrane module is really jumped from 22.25 to 50.1. Meaning that you're producing more than double the water through the small amount of nanoparticle which you really coat it on the membrane surface. So if you do it, membrane technology will really be really cost effective compared to without the nanoparticle which is really coated. Right? And the other side, these membranes also can really be used for stopping any kind of pollutant. Right? This is the pattern we created, membrane on it, and we use this full plate in the small scale reactor. It can be really scalable. The same similar modules can be really developed. And the other side, the membrane technology is used to retain a pollutant like microorganisms, right? In the field scale, you have the membrane cassettes, which is really kept it like this. And each flat sheet is really this, or a membrane fiber, which is really representing this. And conventionally, the biomass is really a suspended material. We use the gravitational force to really settle down in a sedimentation tank, right? We use the membrane bioreactors to basically stop the propagation of the microorganisms outlet, right? So we constructed a small reactor, and this is the hollow fiber big membrane module which we really formulated, and it has 7,000 fibers, small fibers like a straw, and we apply this in different conditions. We find out the estimation of flux. I will highlight only the very important thing. If you see that our standards, right, this is 10 milligram per liter, and the oxygen, it is really 10, again, like the nutrients, which is really much higher level. So initially you have bigger solids here, but it's all really lesser than your dissolved, standard levels. So the water which is coming out, which is really able to meet the standards through the membrane technology. But this is the experiment we have done with suspended biomass. Usually the microorganisms are really float or mixed with the water, and they try to accumulate on the membrane surface. You can see here, when the water is passing through the membrane, all the microorganisms will really attach, right? So what we really doing new here is, these microorganisms are prepared in a bead form. We use different recipes to prepare a bead so that the beads can be easily separated. They don't really attach to the membrane surface. So that will increase the sustainability of the membrane. So it can be operated for a longer time. Then it can be really used as a good technology. Similar thing, we use it for our other purposes also. Now people are looking for why I wanted to go for an aerobic membrane. I wanted to go for an anaerobic membrane process, because anaerobic membrane, you can really produce methane gas out of your waste materials. Some of the researchers in the afternoon session, they will talk more about solid waste and how to convert into a methane gas or a hydrogen gas. So people are looking into this. So you can see here, if the anaerobic technology is put in place, or anaerobic membrane bioreactor is put in place, they will really lead to the generation of methane gas. If you stop here, it will also lead to the production of the hydrogen gas. This is one of the changing scenario from aerobic to anaerobic. 1 kg of COD, if you estimate from the organic material, which really biodegradable in nature, estimated methane production at standard temperature pressure is 0.35 meter cube. It's approximately equal to 350 liter of gas you can really produce from 1 kg. This is the present scenario where you use a sand filter, and the current we have the activated sludge process in combination with membrane bioreactors. In the upcoming days, to sustainable this membrane reactor, we are going to have the anaerobic MBR or solar disinfection combining with other microwave technologies. This is the one example for the membrane biotechnology. In the other side, we do a lot of photocatalytic operation. For example, like the pharmaceutical compounds and the personal care products which we use in everyday life, that may not really getting removed in the membrane bioreactor I shown you earlier, right? Even the microorganisms are present, or membrane is present, they will dissolve solids, they will really have a pore size or the particle size of 0.001 micrometer in size, they will really pass through. So what we do, we really degrade by supplying some kind of an excitation through UV light. Right? So obviously they will produce the OH radical, right? These radicals will oxidize the compound to some other phase. Then again, the catalysts are in powder form, right? Earlier, but we really again put it into some kind of a bead form. So if it is a bead, and it can be really easily settlable, and it is easily really separable from the particular medium, because when these catalysts are really moving along with the water, right? For example, if you wanted to give so much time for settling of the particles, and you are not in a position to give so much of time, and you allow the water to pass through, these particles will also really pass along with the water, and they create toxicity to the receiving aquatic species or the plants. So to avoid that, we really prepare bead-like structures. This is the one example. On the other side, the wastewater, if it is non-toxic, as I said, detailed classification of the pollutant, there are friendly pollutants which is available, and along with the nutrients, this water can be supplied to either a hydroponic system, which is really uptake the nutrients from the water directly, or you can go for the constructed wetlands. The plants which is really harvested, or the fruits which is really harvested from here, can be really utilized for the meeting our daily routine things, and the treated water is free from the pollutants, provided a toxicity of the final wastewater as well as the final product is supposed to be tested here. Due to time constraint, I'm not really showing the toxicity analysis. We also do have a toxicity analyzer. We'll test the samples for toxicity analysis. In the other front, as I said, adsorption is one of the process. So we converted the Procephalus juliflora. It is a weed which is really grow plenty in nature, and it consume your groundwater. So we converted that particular plant into an activated carbon, and we applied for emerging pollutant removal, and we get good result for even the removal of a model antibiotic compound of phosphorus as well as the nitrogen. You can see here the removal was close to 95 to 98%. This is the one idea. And adsorption, usually what we do is we have the water molecule surrounded. In the water system, we'll have the adsorbate in small concentration. So most of the adsorption systems will target removing the adsorbate. This is the one success we got with respect to removal of adsorbate. In the other side, we made the system ulta, meaning that reverse. So what we have done is we produce and hydrogels, right? This hydrogels, when you drop it in contaminated water, for example, the water having nitrate, right? So you drop it there and the hydrogel will absorb only water, but not the nitrate. So reversing your adsorption system, so water will really trapped in the hydrogel and it could able to absorb water 25 times higher than its original weight. So it is reversing your adsorption. So this is also a way forward. We are looking to really take out the hydrogels. We directly put it in the agricultural field where it can really degrade, it is toxic free, and it can really supply the water from the hydrogels. Right. So I'm into the last two slides. I wind up with this. The framework for sustainable wastewater treatment plants would be the concept of wastewater treatment plants supposed to be reversed to water supply plants. So we have to upgrade our systems to the level of water supply plants, and it is only feasible by applying the applied research, effective policies, as the respected director, Professor Neeru, rightly pointed out. It is the combination of management people as well as the scientists combined together and develop the policies, and we'll work it out, the cost of treatment which is involved in it, and to modify it and support the institutional capabilities. The Ministry of Jal Jeevan or Jal Shakti is already doing it, and you have to involve the private sector for implementing it, because scientists may not implement in all places. And you have to work it out sustainable business models, because that is more important. If you have plenty of water, the water supply plant model may not work. Where you have a scarcity, then your water supply plant model will really work, and you have need a lot of advocacy people to really support the policy in it. And if occasional needs, then completely change the technology. Get out of your sand filtration technology, move on to the good policies, good technology like membrane technology or any other thing. Even aerobic process not required, forget about this, go for the anaerobic and optimize the cost of treatment. We are working on developing the new technology as well as coating the nanoparticles on the membrane technology, so that like you can reduce the overall cost which is really involved. And at any place, you really recover the resource. For example, like the nutrients which may be used for the plantation growth in terms of hydroponics or the constructed wetland systems, and use the residues for material production or be used for my agriculture purpose. And with this, I wind up and thank you for the opportunity. I thank the convener and the co-convener, and I acknowledge the funding agencies for giving a lot of funding to carry out my research, and all my research scholars and all my collaborators in the institute in India as well as in abroad. Thank you very much. And if any questions, you can please ask me.
Thanks a lot, Professor Madhava. It's nice to see that you achieved the circular economy also in your research. It is beautiful to see that anaerobic digestion you are doing through a membrane bioreactor, so that you can get biogas from that, and it is completely circular management of every materials you have, and sustainability achieved there. I'll be happy if I can collaborate in near future with your lab activities, as it is the wastewater treatment is near to my heart, as I am from that field. Anyways, happy to have you. We are grateful to have your speech here. Thanks a lot, sir. Now moving to our next speaker, Professor Prashad.
So thank you very much, Arpita. I will be leaving. As I said, I have a class from 12
Yes,
to
yes.
1.
Yes,
So
yes,
if
yes.
any clarification or queries, please feel free to contact me through my email. I just informed the same through participants as well. And all of you are invited to see the lab if you are there in Chennai or IIT Madras. And I look forward to collaborate with you in the future. Thank you very much.
Okay, thank you,
and
sir.
all the very best to the entire team. Thank you.
Thank you, sir.
Yeah, thank you.
Professor Prasad is a senior professor in Department of Civil Engineering at GB Pant University. He has more than 25 years experience in teaching and research. He completed his BTech from IIT Roorkee and PhD from University of Sambalpur. His areas of interest are hydrology, soft computing, application, and groundwater hydrology. He has several research papers and research projects in his profile. Over to you, sir. We are thankful to have you as an expert in this field. Over to you, sir.
Thank you, madam. Kindly give me to share my PPT, please. Please provide rights. Rights to share.
Sir, you have shared content.
Yeah.
Just after stop video, you have another button that is share content.
No, it is not enabled.
Okay, Rijwanji, please, are you there?
Please enable. Please. Yeah. Is it visible?
Yes,
Hello?
sir, it is visible, sir.
I'm audible?
Yes, sir, you are audible, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, thank you, please. Nice to participate in this one-day seminar, which says that act responsible and think sustainable. And thanks to the director, Professor Nilu of IIM Sirmaur, and also host, in particular Professor Arpita and Professor Parul, for organizing this timely and appropriate theme on the day of Sustainability Day, that is on October 27th. And my talk will be slightly different rather than the other speaker will just have it, because it is a treatment. There has to be a source, then only treatment will come. So that's why my thing will, why can't you stop the pollution or whatever that materials are there at the initial stage itself, or the source is important, and there itself, yes, we studied on pollution, but at the source itself we are doing that. I am just taking up in my presentation, and before that it is just a small introduction of the topic which has been shared by IIM Sirmaur. It says that act responsible and think sustainable, and note that today is the Sustainability Day, and today is Wednesday, of course. So note that generally importance of this Sustainability Day is to organize some event or to make it awareness about the sustainable things on this day, and not only aware, but you should act responsible also. That is also important. So that's why, yeah, this is the right opportunity for all of us to think about responsible also. Not only act, that is, we need to act also, not only just think. Okay? Anyway, note that this sustainability needs. Okay? So it says that is already been explained by earlier speaker. You need to meet the needs of the future generation. That is important. Okay? So without compromising the ability of future generations to meet their needs, one has to think it up, and you must focus on the present needs. That's what this sustainability day says. And of course, there are 17 sustainability goals, and out of that, my talk will be on 4, that is quality education, and of course on 8, that is decent work and economic growth, and also quality education. So these 2 goals, keeping in mind, I am sharing my presentation, or I am just doing a small piece of work which we did it in our university, that I am just presenting it to you, or I am sharing with you people on this day. So note that this Indian Himalayan region, it's a vast area. It consists of 11 mountainous states that includes starting from Jammu and Kashmir, including where Sirmaur IIM is situated, that is the Himachal Pradesh, and of course where I am sitting, that is Uttarakhand, and this is the northern part of India, and of course northeastern borders. You can just see over here. I will not read because of the shortage of time. There is Sikkim, Arunachal, Nagaland, etc. So all these things are involved in this Indian Himalayan region, or we used to call it IHR region. Okay? So note that these 11 mountainous states and 4 hill districts of West Bengal and Assam, they have nearly 4 million springs are there. Okay? Because I am just concentrating my talk on springs only. Okay? This is the source for many people. Okay? So in India, particularly north and northern part, there are 4 million springs. Okay? So they are the lifeline for meeting the water requirements of hilly people. Okay? So, and note that these springs, their problem is they are drying up or becoming seasonal. Only during the monsoon season we are getting water in those springs, and for the other seasons there may not be any water, or they will dry up, or the flow will reduce in those springs. And of course, there is a note that because of the tourism related activity, lot of demand is there for this water, because tourism, particularly Government of India is giving a lot of importance to tourism purpose. That's why Himachal and Uttarakhand and even northeastern states, because of the movement of the people, there is a shortage of water also. So that's why we need to see this water conservation part. Of course, waste management is also required. That is pollutant and other things. So note that this is one of the thematic area taken for contributing to sustainable development in this Indian Himalayan region of NITI Aayog, and in our studies we have taken one of that small point we have taken under that 5 thematic working groups, okay, for sustainable development. So note that this 5 thematic work groups includes water security in mountain towns and cities through revival of springs. So that's why our work is related with water security through revival of springs. So that we have taken it up in our studies. And note that this Indian Himalayan region, there is a threat of water shortage. Just now I discussed with you people. And note that there are challenges of this Indian Himalayan region. So there is a changing rainfall pattern, maybe because of the climate change, or just now few days back you saw there was a heavy rainfall even in Uttarakhand also, where I am situated. We were completely cut off from the 2 days. There is no electricity even in our university campus, as a well-planned campus. And even here also there was since there was no electricity, most of the things have been shut down. There is no water also. That sort of things we are facing, particularly Himalayan region. And of course, there may be droughts also. there may be a fluctuating temperatures like climate change and other things people are talking about, and there are more frequent and severe weather events. That is also possible, like western disturbances or like that, including floods. That just now I said a few days back, I think just 10 days back only, we just experienced this flood. Because of that, not only that, even springs are also get extinct and they are drying up. And because of that, huge sedimentation will be there, and there may be some loss of potential for hydropower generation. These are the things which are in process, and that we need to see how to make it sustainable. So this Himalayan water is a key challenge for us. Okay? So providing year-round uninterrupted availability of fresh potable water. And note that Government of India has planned to provide, now it is 2030, complete potable water. So here I've just mentioned some of the challenges. In these challenges, yeah, we are also give importance to reduction in water quality. So that we are looked deep into, and yes, our study focus on all these things. And of course, there may be some data gap may be there. That's why Government of India started 2017. They started identifying the springs, particularly Himachal Pradesh and Uttarakhand. We have a lot of springs. Himachal is more than, this is from India Water Government data. So these are providing water, and Uttarakhand also, there are springs, and also we used to call it as Nola or Gadera. I will just come to that a little bit later. So note that these springs not only provide, or sometimes they are known as Nola, Dara, Shota, etc. Even in Himachal and even in our Uttarakhand also. And note that some of the streams or rivers, they are fed by these springs only. So that's why you must save or you must rejuvenate those springs such that there may not be any water shortage. Anyway, note that this is just a inventory of springs on all the northeastern part of northeastern part of India. Because I'm just moving fast because of the shortage of time. Note that we can just read it from this presentation, or you can have a view. Okay, so these are all available in the Niti Aayog report. Okay, and they are given a lot of importance to rejuvenation of springs, and study about the springs, they are given importance. So note that we have taken, this is mapping and revival of springs in Himalayas is one of the things which one should consider, or we have studied, and note that what can be done for source augmentation, that also has to be undertaken. Not only that, not only source, just now we talked about, that is another expert talked about demand side management. So how to reduce the water demand, that also you need to look into. So note that here is a typical spring inventory template which we use in our study. And note that this has been guidelines are given by Niti Aayog, and of course you can modify as per your local needs also, as per your requirement. And some of the quality parameters which we are studying has been mentioned here also. You can just see chemical characteristics like the turbidity meter, hardness, then chloride, etc. that we are studying. Okay. So here is a typical geo database and geotag of all the springs, okay, of different regions of India. Like this is in our Champawat district of one district of Uttarakhand. These are the locations of the springs. They're all geotagged. We can have a view of that one through their website. Similarly, in case of Mizoram, like that, this spring mapping, there is geo database and geotagging is also important part of this Niti Aayog. And note that around 3,500 springs are invented in 11 states as of now. Still, study is going on at many places, okay, and still many more springs inventory will be done shortly. Okay. This is an ongoing project of Niti Aayog through National Hydrological Project, NHP project. So here is the just a total view of water scarce block in particularly Indian Himalayan region. We just see Himachal is around 19% and Uttarakhand is around 28% also. These blocks are water scarcity. Okay? Particularly Uttarakhand is lot of water scarcity is there because of the terrain which we have it. Okay? And of course, some other states data is available. We can just have a view over here. Okay? So this is the concept which we adopted in our studies. There is only one small part of this one only we are studying. Of course, there is a lot of scope for further studies also. You see, we need to rejuvenate the springs. Okay? We need to see the quality. We need to see the source, and you need to see the demand side also. Demand management also you need to look into. So note that these are the just typical steps for spring management. You need to manage the springs. Okay, so these are some guidelines which have been given by NHP project under the government of India's Ministry of Jal Shakti's point, Niti Aayog, on the basis of Niti Aayog guidelines. So these are the steps which we need to do at a micro level. So anyway, I'm just you can just see the various springs which have been shown in this picture or in this snaps, where some of the springs we have visited and we are studying in our actual studies also. Okay? You just see some of the springs are even they are not only culturally and even they are having religious importance also. That is one important thing. That is, we need to study social aspect also, or social hydrology we used to call it, okay? And religious things also, and of course drinking and other norms will be there that we need to use it. Okay? So and our first MTech student, Mr. Prakash Sharma, and our another professor, Jyoti Prasad, we are involved in this spring quality evaluation of the springs in Almora region of the Uttarakhand springs. Okay. You can just see a typical spring which has been shown here, where our students are collecting the samples for their quality testing, and they just collected from those springs which are there on the entire hilly region, and they brought that sample to our Pannagar campus, where the laboratory facilities are available, and they tested it for their quality. So I'm just moving fast. As I said, this we have already read it earlier, and note that as per the guidelines, we need to go for spring shed management rather than watershed management. I will just show you one of the things where you just see there are 5 million springs across India. 5 million springs across India, out of which 4 million springs are in Indian Himalayan region only. And most of the springs are drying up. And note that spring discharge is declined because of the increased water demand, and there is a land use change. Yes, recently you saw that Uttarakhand floods, which has been happened in Uttarakhand, particularly in the Almora and Nainital districts. There was a huge precipitation was there. It was almost double the maximum it was there. Almost 125 years back, we got around 500 millimeters of 500 millimeters was the annual average rainfall. But this year we got around more than 1,000 millimeters or so as a rainfall in 24 hours. Okay? So there is almost double the usual annual rainfall which has occurred, and because of that, there are landslides and a lot of land use change has occurred, and also ecological degradation also was also there because of this one. So that's why, yes, here you can just see here. I just shown you the springs. What is the difference between watershed and spring shed? So not that we generally, in case of watershed, suppose here is a spring, we used to consider watershed only this part. That is the surface flow only we are considering. But strictly speaking, springs, any spring, it not only gets water from the surface because that is the infiltration part, but it gets majority of this water comes from below the surface of earth, which may be from another watershed. That's why we need to consider spring shed, we used to call it, the water which is moving on the surface or overflow, as well as below the surface also we need to consider. So this is a concept which we need to adopt it, and this is one of the sustainable development goals, but in particular for sustainable development goal 4 and 8, these are related with this rejuvenation of springs, and that you can check it even with your Niti Aayog report also. And note that they are saying full inventory of Himalayan springs and revival of springs is required not only on quantity. Quantity is one aspect, but we should think it of quality also, which are deteriorated at the moment. So that's why we have taken in our small project this quality aspects, of course, in addition to quantity aspects. So we consider a spring shed approach for our study. I'm just skipping all these things because it is just whatever I just shown it here that has been explained in words. Okay, so in case of spring shed, geology and the nature and existence of rocks is underneath the surface is also important in case of spring shed management that we have considered. Summarily, I should say that yeah, there is a paradigm shift from watershed approach to spring shed approach in general. So these things, most of you know, I'm just skipping all these things. Okay? How that the springs will originate from a saturated zone or maybe flow from the other side. So we have studied only some blocks of this Kumain region. It is just particularly in Kumain region, they are calling it as a Dara. It is nothing but a spring only, but the local name is Dara, and you can just see the Naula. Naula is it's a open. It is like an open well, but Dara is flowing through a small stream through some tapping. Okay, so not that here water comes from groundwater, or the water will flow below the surface of the earth. In case of Dara and also Nala, these are nothing but springs only. Only thing is these are all localized names in that region. Yeah, just because of the deteriorating quality, yes, we have given importance to quality. This is the study area. This is just close to Almora town, and you can just see on the Google map which has been shown here. So these are the various springs, okay, which our study has been done. And note that this is also not it is also a part of our park project of Government of India between Australia and India. We are associated with Western Sydney University and Melbourne University from the Australian side. From India, we are associated with Banaras Hindu University and our Panagar University. We are the principal investigation institute is from Panagar. Okay. So this is also part of that study area only. As for that, the project study by Government of India's project scheme for promotion of academic research and collaboration. And of course, we have studied around 11 springs. This is the spring inventory form, which we need to fill it up, or the person who is going over there, maybe our students or maybe some of the surveyors, lab attendants, they need to fill up all this data. So note that this spring inventory form, of course, we are giving importance even for quality also. You just see water quality parameters and also geological part. So this we need to, you can just have a view of this. Some of our students who they are involved in this study, and you can just see in one of the spring, puja, they are doing puja for this spring. This religious importance is also there for that spring. So that's why they are saved, or they are, I should say, they are the source for that water. Ganga Ma, we used to call it at Haridwar. It's a open river, and even, or you can say surface river, but below the surface of the, yeah, I think you know, you might have heard the Saraswati river also. We used to call it as Gupta Gamini. Like that, even groundwater is also worshipped by hilly people. And you can just observe here this Naula. If this is a Naula, here water exists. This is partially dried up here, but still, yeah, you will find a water over here. At the topmost, it has been covered over here. You can just see This is the modified form of that NAVLA that government of Uttarakhand and also in assistance Government of India has done some rejuvenation work, and they made it all these floors and other things in a proper way. So this is the NALA which is existing, which we are studying at home, and our one of our student is collecting the samples for studies, water quality studies, etc. You can just see the different shapes of that NAVLA also. Yeah, this is a beautiful architecture is there. These are old, long back they constructed like this, such that the water should stand over there, and that will be used for various purposes. Okay. You can just see some modifications or has been done for that Tara, and yeah, it is in a good shape as of now. And they are collecting the various in situ equipments they are using for collecting the water to find out quantity and quality. So these are some of the pH meters, TDS meters, EC meters. They are used for in-site water quality parameters testing at the site itself, because to bring it from the hilly area, it will take around 4 to 5 hours from that place to reach to Pantnagar. So they did it on the spot testing of all these things. So these are some of the parameters, and the instruments which have been used have been listed. Most of it are aware of all these things. I will not explain in detail. Okay. So all the physico-chemical parameters have been studied by us, and later on, yeah, we analyze the data for various purposes of these physico-chemical parameters, and of course, this acceptable and permissible limits as per India standard 10500 2012 we have followed, and as per that, yeah, we just we could identify that, okay, at some of the places, okay, at some of the places is hardness is very high. Okay. Acceptable limits is 200 mg per liter, but we got more than that. That means that it is a pollution has occurred in springs. Okay. Just these 3 springs, hardness is very high. Similarly, pH is also at some of the places is low. You can just see here 6.4, 6.4 like that. But in general, even in potassium also at some of the places it is exceeding the acceptable limits, but that is fine. Okay. Anyway, note that since all these things are within the permissible limit, I should say, or we are come to the conclusion that in general, all the springs water is quality wise, it is fine, even though it is a warning that yes, at some places going to be polluted. Okay. That various graphs have been studied, okay, of all the springs. You can just see comparison of all these things, variation of pH, TDS, EC, and hardness, etc., and including alkalinity, chloride, sodium, and other things. Okay. And of course, there are some statistical analysis has also been done, including error, deviation, variance, all these things, etc. And they found out at some of the places very good correlation between EC and TDS, and chloride and TDS, and at some places there is no correlation at all. So these statistical analysis has been done, and they are plotted for 28 different correlations have been plotted for all the quality parameters. I am just skipping all these things. Finally, as I said, yeah, the springs water found to be slightly acidic in general nature, but otherwise this is fine. Okay. So that is the thing which we are observing, and just 3 springs shows hardness, and all other things are fine, or in general it is in which is the permissible limit, but they have crossed their acceptable limits. So this is what we want to say, and note that on an average, okay, these water sanctuaries, okay, should be saved, okay, under various schemes, Jal Abhyaranya scheme. Okay. So this one has to think it of in my summary. So thank you once again. These are all the some of the references which we have taken. So thank you. In case of any queries, I just exceeded a few minutes. I think I am on time. Thank you, Professor Arpita. If any queries or if any things are there, let me know. I'm just stopping the sharing. If any discussions are there, I'm happy to answer all those. Thank you, Dr. Arpita, and also Dr. Parul, and also IIM Sirmaur director and their entire staff for providing me this opportunity to present the small work which we did as part of our sustainability contribution on the day of World Sustainability Day. Thank you.
Thank you, sir. Thank you, Professor Prashad. Professor Prashad, it's nice to know that you are working hugely in spring shed management, and it's also very informative. Your presentation was very informative, and also we get to know that watershed management is being obsoleted day by day, and we are moving towards spring shed management. That's the beauty of the advanced technology and science, that again we have to go for spring shed management, and spring water is also full of different minerals. Thanks for coming, and thanks for having you as expert.
One more thing, as the director said, we are also happy to associate with IIM Sirmaur in various, particularly because ours is spring shed management. Without management, we can't do anything by the technical side. So we are happy to associate with young and energetic faculty, and even IIM Sirmaur is also young. Yeah, they have a lot of potential. We are happy to associate with them in any of our projects or in our.
Yes, sure, sir. Sure, sir.
Yeah,
I'll be also happy to collaborate if I can contribute with my expertise in different waste management or wastewater treatment and testing facilities. Thanks a lot, sir. Thanks a lot. So.
Ma'am, you're not audible. Arpita, ma'am.
Muted, madam. It is muted.
Yes. Thanks a lot, sir. We could not see any question till now from the participants. If they have, they can share it afterwards. So we are before going for lunch session, we do the vote of thanks, and also let them to know about our next session plan. That is, we have another 5 speakers from different IITs and industries, and also reputed research field in solid waste management in this seminar, and the seminar will start after from 2 p.m. after the lunch. So we are very happy to have director ma'am, honorable director ma'am, with our visionary plan and enthusiastic CSM towards this sustainability area in planning of different activities, academic and research for sustainable world also. We are happy to have Professor Madhava from IIT Madras and to have his informative presentation on MBA technology along with anaerobic digestion. Thanks a lot, and we are also very grateful to have the senior professor with us, Professor Prashad, as an expert in this seminar, and for his informative presentation on spring shed management. We will be happy if we can contribute something towards any future projects of of your institute, or if we can something add some policy recommendation or circular management or different water testing things. Thanks a lot. We are in closing this first of session of the seminar, and I request to participants to please attend the seminar thoroughly to get so that you can get the e-certificate. Otherwise, it is not fruitful for have the certificate participation certificate if you do not attend it completely. So we are very happy to have you all. Thanks a lot. Thanks a lot, sir. Thanks a lot. Thanks a lot to all. So we are moving towards our lunch breaks, and then we'll start again from 2 p.m. Thanks a lot.
That's when we saw a lot of movement happening in this area. So having said this, my journey, my personal journey, something that I would like to start with, for me, frankly, waste did not exist. So all these years which I grew up and I was working, we were like, for me, the house got cleaned. I stay in a campus which is very well managed. Waste was collected and it would go to any place, and I did not care. It's not that I did not care, it's just that I was not aware of it. It was not in my consciousness. So for me, waste was out of sight, out of mind, till the time I joined Sahas, and Sahas also happened by chance. And that's when my journey with waste started. And I realized how important waste is a component in our lives, in our daily lives, and how important it is in sustainability. Whatever we do, wherever we are, waste does not leave us. There is waste everywhere. We create waste in every area that we work, in every sector that we work. And that is a very important component which will help us. If we address this, it will help in sustainability. So if you look at the SDG goals that the UN is working on, 2030 goals, waste plays a very important role in all the goals. Each and every goal will get impacted if waste is handled. So on a larger scale, those are the larger ones that I'm going to talk about, and the time is too short to go into details. But I just break it into a little one, what you and me can do to make a difference, and what we can do to collectively with all the stakeholders to bring around a change. So let me just go through a couple of slides that I have to maybe arouse the fact that what waste can do and what it does. We all have seen this beautiful Taj, which is a world famous site, but even Taj has a lot of waste sitting next to it. And why I'm showing you this is because this is something we are very proud of. As every Indian, this is one of the old 7 wonders of the world. And here also we don't leave it. Here also waste is in ample. And if we talk about some statistics, the waste that is generated across the cities is simply huge. So if you see the center portion, it's a clip of a newspaper which talks about the waste in Delhi, how high the dump yard has been. And this is a 2-year-old clip. So we have the dump yard in Delhi is about 65 meters, which is just short of Qutub Minar, which is like 72, 73 meters. And the allowed height of a dump yard is just 20 to 25 meters. So if you see, the waste is all getting piled up in dump yards. It is not being processed, it's not being managed. We are into this whole system of just creating waste and then dumping it. And in terms of what is being created, to give you examples, Delhi generates more than 10,000 tons 10,000 tons. 1 ton is like 1,000 kgs. And to give you an idea, in a household, we generally end up generating about 1 to 2 kgs. So Delhi as a city handles 10,000. Mumbai generates 8,000. This is a figure that they have declared. We can always debate this figure. Hyderabad, a much smaller city, generates 5,000 tons. And Gurugram, which is a very, very small city as compared to these large cities, Gurugram also generates 1,000 tons of waste every day. So the generation is huge. And today, what is happening to this waste is it either goes to a landfill. When I say landfill, it actually means a dump yard. That is what it is. It gets dumped, it gets burned. The basic way of handling waste in a country is burning. If you go to the villages, if you go to every corners, it's winter timings now. The instance of waste burnings are going to be much higher, and burning is a very normal norm. When we go to villages and we work, the best practice that they handle, they say, is burning of it. We collect it and burn it. And that leads to a lot of problems. So if you see, when waste is dumped and it is burnt, you have health hazards, obviously. It is decomposed, it attracts all types of bacteria. When you cross any area which has waste, the first thing that you do is you close your nose. So all this is, that's because the waste is getting decomposed there. It is decaying there, in fact, and it attracts a lot of bacteria, diseases happens because of all this. When you burn and dump waste again, the limited resources that we have in terms of air, water, and soil, all the 3 important components is polluted. Methane and other poisonous gas gets released from mixed waste. So if you see the food waste that we have, the moment you close it in a bag and you throw it, it generates the gas called methane, and which is critical. That is what gives you that dirty smell. Methane leads to a lot of fires in the dump yard because it has a low ignition point. So methane gets generated, it pollutes the air. The leachate that comes out of the waste, that black dirty color liquid that comes from the waste when you pile it together, that's called leachate. That contaminates the water and the soil. And in areas very close to dump yards, today this leachate is actually touching the underground water, which is very dangerous. It is very difficult to then control that. In addition, if we talk about the greenhouse gases impact, methane produced from this waste, it is much more harmful than even carbon monoxide. It is 250 times more harmful than carbon monoxide. So if you look at all this together, just the waste itself is leading to a lot of issues in the environment, which is today what we call about climate change, and hence the sustainability of the planet. In addition, it is taking up a lot of land. In any town, any village, any city that you go, waste is being dumped. And today, if we actually gather the entire waste of a country, one day waste will wipe off the city of Guwahati. That is the type of waste that we are generating. And if we continue to do this, we will have no land to put our waste, to at least add the waste. Apart from all this, what happens is the children, they work in very, very bad conditions. And I'm sure you would have seen this. And as this society, we also have responsibility towards everyone. So while we are destroying our own Mother Earth, we are also not taking care of the people, the society that we have on this planet. So how much of waste do we generate? I did mention that at a household, we look at maybe 1.5 kgs, 2 kgs. And the waste generated in the city is much more. And it is very obvious, in a city, we have more purchase power. In a city, we tend to use more, actually it is purchase power, which brings out to the point out here that the wealthier we grow, the more waste we generate. And this waste that we generate is all packed up together and just thrown. And giving us some examples on our wasteful lifestyles. These are again, it becomes important for you to actually understand what is it that we do in our lifestyles, where is the waste being generated. So if we talk about 1 liter of water bottle, that what we buy, to produce that 1 liter of water bottle, there is 7 liters of water that has been used and 250 ml of oil that has been used. And this water bottle that we use, we just use it and we throw it once. So there is upstream waste that is being created, and then we use the bottle and which stays in the environment for years to come. So the second example that I would like to talk about is the diapers that a babies use. So in a 3-year-old, by the time a baby is 3 years old and continues to use a diaper, approximately 4,000 diapers are used by that baby, just one baby. And now just imagine one diaper, 4,000 diapers, how much of space in your home it will take. So that is what is being produced. And this is like, it uses up 16 trees and 1,000 liters of crude oil. And something which our earlier generations did not have. They did not produce this waste. So with these two examples, I'd like to bring your attention on the third point, which says that 1 bin of consumer waste. It actually means 70 other bins have been produced by the corporations in the process of production, from mining to extraction to manufacture, distribution, and marketing. So what I'm trying to actually tell you is, if you see the bin which is at your place, your office, your home, that is the waste that we have created. But the upstream, that means the waste that has been created for the products that we have used and put it in that waste bin, 70 such bins have been created already. So every day when we take out just one bin from a home, it is not one, but it is 71. It is 71 bins. So that is the type of numbers that we are talking about. And what happens to all this waste that we actually have? I mean, do we really throw away? There is nothing called away. Everything comes back to us. So what is it that you and me can do? What is it that we need to build in our own systems is what we call the waste management funnel. This is the basic funnel. We talk about larger numbers. For example, reduce gets, there are design elements that come into picture. But the basic systems that what an ordinary citizen can do is look at these factors where we talk about reduce, recycle. So reduce, reuse, recycle, recover, and landfill. What it says is our maximum energy should be towards reducing waste. I just spoke about how much waste we generate. So if we reduce even 1%, it has a huge impact at the back end. Whatever you cannot reduce, move into using those products which can be reused. So that again, that leads to less production of waste. Whatever you have reused and you need to throw it, let it get into the recycling chain. So for this, very important to understand is that the products that you use should be recyclable. And you need to work on ensuring that it goes into the recycling chain. And that's what I will again touch upon. What do you do? What is the call for action for recycling? And whatever cannot be recycled, then that is the work that starts from the government angle in terms of handling of the waste. So there you can recover energy. So that's one way of waste disposal. And whatever minimum is then left goes to a landfill. So if this is followed, we will not have dump yards and the landfills that we have. And the single practice of recycling, ensuring that recycling is happening, the waste that goes to a landfill is reduced to less than 10%. But if you see today, what is our practice? It is absolutely upside down. We use and we throw it in the landfill. We use and we just dump it. It's all very linear. And there is hardly any attention or focus towards reduction of waste. So from a linear to a circular economy is what our steps are. As I said, today the current disposal methods of waste or our actions are all linear. We generate waste, we club it together, put it in a bag, and we just throw it. It's collected and it goes to the landfill. But if we move towards a sustainable living, then this method needs to be converted into circular economy is what we call it. If you see the below portion of the slide, it talks about the source, which is generating waste. It is segregated at source. So if you know, we talk about gila kachra, you have to, gila sukha kachra, you have to segregate waste at source. So you segregate this waste. It is collected in a segregated manner, and then each category of waste is further processed so that you can recover all of it, which comes back to us. So for example, the wet waste, which is the food waste, and that is the maximum amount of waste that we generate in terms of weight. It is 50 to 60% of the waste that we generate. So this gets composted, and once it is composted, it's a manure. It comes back to our lives. It goes into the soil. It enriches the soil. It replaces the very unsustainable urea manufacturing. As you know, when we manufacture urea, all these chemical fertilizers, it is very guzzling in terms of natural resources, the amount of water it takes, and it's a huge industry at all. And it is spoiling the soil for its longevity. So now if you replace that with compost, it is not just that you're adding good nutrients to the soil, you are also doing away with these chemicals. You're doing away with the harmful impact of this entire industry. So compost, which is like wet waste, which is 50 to 60% of your waste, goes back into nature, which again gives us material that we can consume. So the next waste that we talk about, it is like the dry waste, commonly called the dry waste, which is non-biodegradable waste. It is typically a paper, plastic, metals, and all this related stuff. There, it goes for your recycling. The moment you so segregated it, it becomes a good raw material for recycling. To give you an example, if you mix the waste, paper, by its very nature, it absorbs the moisture from the wet waste, from the food waste, and hence it gets soiled. It can no longer go for recycling. But the moment you segregate it, you put the wet waste separately and paper separately, then paper it has an excellent recycling capacity. So, and the industry is also there. So it goes for recycling. So hence, source segregation becomes very important to see that the waste resources are recovered. And the third category is what we call the domestic hazardous. Now, this category is very important to understand from the perspective that there is a large sector of people who work in waste. When we throw waste away, it is further processed by these waste workers, these rag pickers. And if there are broken items in this, you have needles, you have broken glasses, you have diapers, you have maybe sanitary napkins, you have bandages soaked with blood. These items actually has a lot of health hazards to the waste workers, and they don't actually have any recycling potential. So the third category is for these categories of items which don't have a recycling potential, or even if they have, they need special conditions to handle it, to further sort it. So that is one category that goes in, and the other category that goes in which doesn't have, like for example, the dust at your home when you sweep the floor. That dust it just sits in the environment. It's called inert. So that also goes to the landfill. So this third category becomes very important. And this is less than 10% of your waste, of your daily waste. So very important also, this category is, suppose you are confused, where do I throw my waste? Should I throw it in the biodegradable or should I throw it in the non-biodegradable bin? It is best to throw it in the third category because you would continue to keep your first two categories clean. And the first two categories actually is your 90% of your waste, where it can be recovered as a resource. You don't want to destroy that. So hence the source segregation becomes very important into these three categories. And we have seen from our experience, we have worked across cities, semi-urban places, in villages, that once we do start this practice, there is 90% of the waste that is recovered as a resource. So what goes into a landfill or what goes into a dump yard is less than 10%. So as an individual, as a person, the first step that we can all take towards is, source segregation of waste. And that is the first step towards sustainable living. When we talk about sustainable living, we talk about, I will not take plastics, or I will try to use public transport, or, I will replace a lot of product with sustainable products. Now, these actually call for a lot of effort. It is expensive. It is not that everyone can pick up. A common man will not look at these things. And it does bring in a lot of lifestyle change. But source segregation is something which is low cost. Everyone can do it, whether they are rich, they are poor, whether they are in an institution or at home. This is something which is doable at every point, every place. And this has a mass impact if everyone starts doing this, the impact is much bigger than 0.1% people talking about replacing certain products with sustainable products. I'm not saying that is not required, that is equally important, but to have a mass impact, this is the area that we're talking about. This is the area that each one of us can work on. So, these three parameters that we come across, reduce, reuse, and recycle, because something which is very close to I. This is what I can do. And this is what we look at, that every step, every moment that you walk on in your day, think about these things. Can I reduce the waste? So just think back and see from morning till now, what is the waste that you have generated in the day? You will come across, maybe you opened a new packet in the morning, maybe a razor you opened, there was a packaging waste there. So what is it that I can do to reduce waste? The 3 R's, reduce, reuse, and recycle. There are certain examples which I can talk about, and I'll quickly skip through the presentation here because of loss of time. So when you talk about reduce, you can talk about having a water bottle. So along with your wallet in the morning that you pick up, whenever you're stepping out, please pick up a water bottle, maybe a bag, a shopping bag, a hanky. These are 3 very important things to be picked up, and it really, you will see over a time, you have been able to reduce waste. You can just ban disposables. You can go in for a long-term solution. You have cutlery banks in a cities working, which you can borrow cutleries when you're having parties or when you have to do some entertainment. Those the ones. Third one I would like to talk about is, using those cheap wrapping papers, which we use during all our giftings. With Diwali around the corner, I'm calling this out because you will end up using a lot of this, and these have no recycling potential at all. So please replace it with newspapers or brown papers. Be creative, make it very interesting, paint on it, put some pictures, but don't go in for these plastic shining wrapping papers. So that's what I would like to say as an individual, what you can do. And that is reduce, reuse. And the third category of recycling, the action is segregation of waste. As an individual, this is what we can do. So as I said, it is into 3 categories: the wet, the dry, and the domestic hazardous. And a home, if you see, the wet waste is 60% from a home. You can compost it, and that becomes manure for the soil. Dry, it is recyclable. You can recover energy out of it, and less than 10% actually goes to the landfill. So that's one way of handling your waste at home as an individual, what you can do. And this is what it is at my level. So behavior change becomes very important. And these are the call for actions, 3 R's. This is where I will bring it down to my action. But having heard what was talked about in the morning, I would really like to share certain thoughts on a larger scale. As students working in this area, as research happening in this area, when we talk about, again, bringing it back to reduce, how do you reduce waste, or how do you reduce in a systematic way with a larger impact? And there I would like to talk about, I would like to give you one example. So basically, if you see a PET bottle, which was used to hold water, so a couple of years back, it was nice and steady. And I recently heard one of my family members saying कि आजकल तो quality इतनी खराब हो गई है, आप देखो bottle कितनी flimsy होती है, पचाक से पिचक जाती है. People are just degrading the quality. So it actually sent me thinking that why did this happen? And it actually happened because of the idea to reduce waste. So before, if there was 100 grams of plastic that was going in making the PET bottle, it was redesigned. That's where the R&D efforts was put in. It was redesigned to make it to be made from a 50-gram raw material. So from that same 100, now you can make 2 bottles, which is used only once. And there is more work on that now, because it was very flimsy. The water had to be filled, but there was still a little gap left on top. So therefore, another thought that went in was, how do you stabilize that bottle, at least till the time it is holding water in it? And that's when the decision came out that we will actually put some air into it. So there's nitrogen which is pumped into that small area. So when you open the bottle these days, you will hear a fizz sound. That's the gas getting leaked out. So this is the thought that went behind in making and redesigning the bottles to reduce waste. But end of the day, we need to remove this waste at all completely. Let it be only for those times when there is disasters happening and we need to send food material and waters to areas that cannot be reached. That is where we can use these bottles. Otherwise, in our daily lives, we really don't have to use it. So in terms of an institution which is working in this area, and all of you who are going to step into this sector, it becomes very important to look at waste as such, which is generated and can be converted back into resource. So very important thing that comes into picture is standardization. When we talk about plastic waste, when we talk about packaging waste, today the challenge is that we don't know what is going into that material. You know, something that looked like paper, now to improve the shelf life, it is laminated. The moment you laminate it, then the material changes. It cannot be recycled because the paper and the lamination are fused together. Even if you're able to take it out, the laminated is not recyclable, the paper is. And the plastic industry, if you see, it is very difficult to handle because we don't know what material is used in virgin plastic to make it into the end product. And even if I am an R&D institute, and if I want to do R&D to take out the components of a packaging material, whether it is thermal or chemically, to reproduce it back into the same material, I am at a loss because every time I have a breakthrough, there is something new that is being used for manufacturing. So, you know, bags, they all get recycled into a lower quality bag. The black ones are horrible. So you don't know what all components go into that, what all elements go into that. So very important work that needs to be done is standardization of the product. These are the 7 elements that will go towards making packaging waste. Once the standardization happens, then there is an industry that will be able to take out the raw material as such from this product and then recycle it to make a similar product. And that's what we call the circular economy. That's what needs to be done. So as you know, I've put this thought across because of the audience that we have here. These are the areas that we would really like to work, and it is great that the sustainable seminars is in place, and we hope that we send across the right messages across. So multi-stakeholders can work together and bring around a sustainable living. So that's all what I have from my side as of now. Summarizing, call for action as individuals, let us look at our 3 R's: reduce, reuse, and recycle. For recycle, we need to do source segregation of waste. That's it, period. But as a part of a larger ecosystem, let's look at systems putting in places on how to waste is handled. You know, that side, how do we reduce waste? How do we bring in standardizations in the industry and work in those areas where we hope IIM will bring in their strengths to build the advocacy around it. So thank you.
Thank you so much, ma'am, for sharing such an informative presentation with all of us here today. And really, I'm so aghast to see that Qutub Minar length dumpage size. And I believe by, you know, having this knowledge of management, waste management funnel in 3 R's, all of us here can, you know, make us a little bit of a step towards acting responsible and conserving our mother nature. It was such an informative presentation, ma'am. It could, you know, everyone, the layman could also connect with it, what they can actually do as stakeholders. Thank you for taking out your precious time. And certainly we would in future as well, we would like to, you know, connect with you and act towards this sustainability. Thank you, ma'am.
Thank you. Thank you so much. So Dr. Parun, I'm not able to stop sharing my screen. So if you could just do it from your system, please.
Okay. Dr. Arpita, can you please do that?
Okay, I can see the screen.
Okay. Thank you once again, ma'am. And definitely, we will definitely connect with you in future as well.
Thank you. Thank you. Thank you. Thank you, Ms. Gupta.
Thank you so much. So moving ahead, now we have Professor Anurag Dirk from Environmental Science and Engineering Department, IIT Bombay, with us. Am I audible, sir? Professor Gerk?
Yeah, you are audible. Yeah.
Yes. Thank you so much. A very warm welcome, sir. And thank you for taking out your precious time for connecting with us today.
Thanks. Thanks
So,
for the invitation. Yeah.
thank you. So let me give a brief introduction about Professor Gerk. Professor Gerk received his doctoral degree from IIT Roorkee in 2005. Professor Gerk is having an expertise in municipal solid waste management, industrial wastewater treatment by wet oxidation and other AOPs, energy from waste, hydrothermal treatment of sludge and organic fraction of municipal solid waste. Professor Gerk is serving as an expert member on several committees formed for municipal solid waste management and industrial wastewater pollution. Professor Gerk has also won various awards and fellowships, including nomination for INSA RSC Bilateral Exchange Program for Scientists by University of West of Scotland at Paisley, Glasgow, and Honorary Research Scotland and Honorary Research Fellow, University of KwaZulu-Natal, Durban, South Africa in 2012. Professor Gerk also received the Best Paper Award in an international conference on technologies for sustainable waste management in developing countries, Ventur, India, in August 2013. Over to you, sir, and a very warm welcome. And now all of the participants will be, listening to your enriching experience on solid waste management.
Okay. So thank you very much, Dr. Parul and Dr. Arpita. Thank you very much for your kind invitation. And I am also happy to share some, basic fundamental, actually, this information about municipal solid waste management, right? So we are actually actively involved. In fact, I started my work since 2005 when I went to England first, and then actually there I worked on municipal solid waste for 2 years. And after coming back to IIT Bombay, so like I joined IIT Bombay in 2007, and then since then this is one of our focus areas, research areas. So we are in fact working with the Municipal Corporation of Greater Mumbai, BMC. So that is one of the biggest municipal corporation in the country actually, and they have a dumping site which is somewhere around 140 hectares or so, right? So it's a very, very big dump ground where the height is almost 50 meters. As per the newspaper, it is 50-meter waste height, right? So that is actually, so this is a huge problem in fact, and they have actually built a plant also on municipal solid waste management, a separate plant also, but still a large fraction of their waste, it is going to the dump yard, right? So they are actually looking for the solutions and all like this, right? So anyway, I will actually share some of the basic information about municipal solid waste, because I understand that the participants are from, or attendees are from, diverse background, and it's kind of a awareness this program kind of thing, right? So that I will start sharing my screen now. Can you see my screen now?
Yes, sir. It is visible.
Yes, sir.
So the title of my talk is Solid Waste Management, Reuse and Recycling Options. So these are these sites you might have already seen, right? So there is the waste is there that is dumped near this river bank and all, and then some of the waste that finds its way into the river water and all, right? So these things actually they are highly toxic materials. Some materials may be present because this is a mixed waste. Otherwise, municipal solid waste, by definition, it is considered non-hazardous waste. But since we do not segregate, right, so in most of the places, so it also contains some toxic materials that may also leach out and then go into the water bodies. And you can see that people are collecting the waste. So this is completely unhygienic conditions. They don't have any gloves, they don't have any protective gears and all. And so they are actually working on the landfill site. But at the same time, there are some places where the waste segregation has also started. So this is like, so there are 5, 6, these bins are there. You can see in the tricycle, and in this bins, actually the different type of waste is collected. So similarly here you can see, so in the south, actually at some places you will find such practices. So situation is improving. So situation, we cannot say that situation is not improving. Now people are more aware than earlier, and because it is actually, it is highly it's a material which has very high potential for the contamination to the environment. Now, this is the outline of my presentation. So this is municipal solid waste generation and disposal practices responsibility. So I would like to discuss in brief about the responsibility of waste generators as per the solid waste management rules 2016. So which are actually, so earlier we had solid waste management rules in like so that name was also different. So that was in 2000. Now it is the modified version. So this is solid waste management rules 2016, waste hierarchy, MSW reuse and recycling options. And then I will discuss in brief about plastic waste. So what are the different types and what are the resource recovery opportunities, and this. So I think that I need not to go through this definition. Everyone understands this thing. So this is taken as solid waste management rules 2016. So any solid or semi-solid domestic waste, sanitary, commercial, so all kind of waste, but it does not include industrial waste. Industrial waste, process waste we are talking about. So if it is coming out from some process, biomedical waste and e-waste and battery waste, right? So these, excluding this, so basically these contain hazardous components which do not which are not the part of municipal solid waste. Now it is a just to give an idea. So there are one in 2016 our population was 1.3 billion, and then 62 million tons of MSW was generated. That was the estimation. So still see, this is just an estimation. We can't say for sure that how much waste is actually generated, because some of the material which we recycle from our home, that does not count towards the waste amount, right? So that is actually generated. So this is 62 million tons, out of which only 63 million tons waste was collected and 20% is processed. So you will see in one of the other slides, now it is increased to 25% or 26% like this, right? So this is actually, this data is taken from this manual. So that is actually CPHEO, that is from the Ministry of Urban Development. So this is now its name has changed of Ministry of Urban Development. So they have given this these facts and figures. Now here it is taken from one literature. So where you will see that how this urban population is, like what is the urban population, and then this is low income country, this is low medium income country, upper medium income country, and high income countries. So this is the population that is given in 2010, and what is the estimated population in 2025. And then waste generation. So this is in the low income country, the waste generation is very low, because there you will also see this per capita waste generation is also low. Low, medium. So as the status, as the economic status of a country is increased, then actually the waste generation per capita is also increased, right? So that depends. So it is one of the factors. It affects the waste generation rates and all. So there is like our lifestyle, our habits and all. So you will see here. So this is like it is predicted that in lower middle income countries, the waste generation would be far higher, right? So this is 369 to 956. So the population is, in fact, this is ratio of this is much less compared to the ratio of waste generation, right? So that is because they are growing also, and then we are developing. So India also comes under this lower middle income countries. So there, in fact, we are increasing, and these are developing economies. So they are actually they are expected to grow, right? So due to which the waste generation rate is also expected to grow. And there you will see in high income countries, the waste generation would be less, because already they are generating per capita waste. If you will see there, this is point, uh, this is given in year. So kg per capita per year, that is 777 compared to 288 or so, right? So that is very less. So in India, typically, if per day we talk about, so in India, it is widely varying. So it depends upon the city, and also it can be as low as 0.15 to 0.2 to 0.8 or something, right? So on an average, we take it 0.4 to 0.5 like this. Now, collection efficiency is also poor in the other, like lower middle income countries. So in high income countries, it is 98%. So this is just fact. So we should not consider then the exact values. So this is just giving an idea, right? So because this is anyway, these are the predictions which are made, which have been published. So we should just uh, think them like as a, we can consider that what will happen in future. So in our country, like waste generation rate is going to increase. Also, we have to improve our collection and all. So then once we will improve our collection efficiency, then we have to actually uh, increase our capacity of waste treatment and all. So we have to think in that line, right? So in future, that our waste is going to be quantities are going to be very high. Now here in this table, I am trying to show you the difference in the composition of waste in developing nations and developed nations. So China, Thailand, and India, they are developing economies, and USA and UK, these are developed economies. So if you will see this green color, that shows these are biodegradable material. In newspaper, there may be like, in newspaper, sometimes it is difficult. So basically not biodegradable. Biodegradable word is not correct for this. It is actually biomass, biogenic fraction, which is produced from biomass, right? So compostable yard trimmings, food scrap, that all comes from biomass. So this is in green because actually here this material is considered carbon neutral. Okay, so the paper is also comes from wood, and wood is actually biomass. So you can see that in developing nations, this is food waste or compostable waste that is in large uh, fraction, right? So that is, and this is a very uh, again, these are some indicative values only. So you should not consider them the final value. And actually, it varies. I will show you in the next slide that how does this vary even in India. So but in USA and UK, you will see that it is a lesser amount, and here paper is quite high. In India, paper is very less. Plastics is also less. So and wood material is also high. In India, it is not given here. So, but the other thing that is important, this is the moisture content. It is quite high in comparison to the to USA and UK, right? So this is basically why it is required, because then we can think that if we are mixing the waste, if we are not segregating the waste at source, then in fact we are increasing the problems for municipalities for segregation. If the material is more sticky, then see, we have mechanical operation equipments and all which can segregate, but their efficiency is not good for actually for the waste which is relatively drier. So for example, if it is containing 30% moisture content, the efficiency of this similar machinery would be far better, right, for segregation. So therefore, it is very important for us that we segregate at source. And in India, approximately 80 to 90% of the total money that is spent only on the transport and collection, this collection and transfer activity. So here, just I am trying to show you, this is the difference in the waste characterization, waste characteristics. So all these are taken from one paper, but in Delhi it may be higher at, so it depends upon the sample to sample, right? So that is, so that variation, I am just trying to show you that their variation may be much higher. So it is a heterogeneous mass. You can expect very large variation. Therefore, it is very important if we are doing source segregation. Source segregation actually help us in finding more homogeneous material which is easy to handle and which can be easily used for resource recovery. And it is cost effective if every citizen of India is doing on its own, on his or her own, right? And calorific value is also very low here. Generally, calorific value is high, very low. So this is in different uh, cities in India. So this is 8 cities that I actually picked there. Now here, this is the status. It is published in 2018, so not very recent, but still it is quite useful in fact. So there are top 10 states. So Delhi generates 10,500, Maharashtra 22,570, and in Mumbai, actually, Mumbai, in fact, 3-4 years back, they were generating around 10,000 metric ton. Okay, so now corporation claims that it has come down to around 7,000 metric ton because of the involvement of bulk generators. They are, in fact, they have to treat their waste at their place. At the same time, corporation has opened several recycling centers which are run with the help of NGOs. So there are approximately, as far as I remember, it is around 40 recycling centers they have opened. So the waste which is collected from the homes, that is first sent to the recycling centers where some recyclable material is separated, and the only non-recyclable, it is actually diverted towards the um, uh, to the dump site. So in this manner, they were able to, and also several societies, as I told you, bulk generators, they have started uh, segregating the waste at source, and then they are treating it. So that waste is also not going to the dump site. So it is approximately 3,000 has been reduced. So earlier it was 12,000 also some time ago. So out of 12,000, it was 2,000 was construction and demolition waste. Now construction and demolition waste is not collected with this. So 10,000 and minus 3,000. So approximately 3,000 they are able to, recycle or use at the source of generation. So it's a significant improvement if we see overall in their this strategy. And there are some states where waste processing is almost negligible. So you can see that is up to 6% and all. So of course, this is not the latest one. So but still we can see from this table that there is ample room for the improvement. Right. So now coming to this solid waste management tool. So I think one thing that I wanted to why I wanted to highlight this, because all of us should know that what are our duties. So I will not go through all the points except a few important relevant points here. So bulk waste generator, what is bulk waste generator? Which generates 100 kg per day. So these are the various buildings and the central government departments, state government departments, and all universities, colleges, educational institutes, hostels, and all. They comes under this establishments. These comes under this. So which are generating 100 kg per day. Biodegradable waste, any organic material which can be degraded. I hope that everyone understands. So combustible fraction, extended producer responsibility. So this is a guiding principle. So they are actually, this is the responsibility of the producers to take back their product after their lifetime and dispose them safely, right? So this is basically for the e-waste and all. That is something that is implemented, right? Now this is co-processing. I will skip this. So decentralized processing, this is the another thing. So establishment of dispersed facilities for maximizing the processing of recovery of waste. Now refuse dried fuel, it is the combustible fraction. So now what is the duties of waste generator? So we have to segregate into 3 bins. So one is biodegradable, the another one is non-biodegradable, biodegradable, or we can say broadly wet waste. Non-biodegradable, which is dry waste, which will have combustible material as well as some inert material, and domestic hazardous waste. And domestic hazardous waste, it is very less in amount. It may have batteries or your tubes and all, so CFL and all these tubes. So it is in very small amount, but if it is mixed with the wet waste, then it reduces its performance significantly of any biological process, right? Because these metals, even in small amounts, these are toxic, not only metals, but some organics may also be present, which are very toxic to the microbes. Should not burn or bury the solid waste on the street, and there should pay user fees. So hardly we pay actually some good amount to the corporations, right? So nowadays, actually, at least in some metro cities, I think that they are going to fix some fees for this. So this comes under this property tax and all that we are paying this, but that amount is not very significant, right? So which is required actually to maintain the waste. So this is the another thing, to organize a gathering of more than 100 persons, intimate the local body at least 3 working days in advance, and ensure segregation and this. So this is the another important. So most of us, like, we live in the gated communities, housing societies or institutions where the area is more than 5,000 square meter. So they have to ensure segregation, and then they should actually have the processes for like composting or biomethanation process for treating the waste within their premises. Of course, here urban local authority has to help them how to set this up. So this is a very generalized MSW scheme. So I will not go this, just collection, the community bin, and then transported, and most of the times it is going to the landfills, right? And processing can be done. The problem case is actually when we are just sending the waste to the dump site, right, without any segregation. So there is not proper collection. So then people will throw their waste here and there. So you can see the heap piles of the waste roadside and all, which is not collected. And then actually, if it is dumped just in an open area, then their biodegradable material will start degrading, and then methane will also generate, which is a greenhouse gas also, right? Which is a greenhouse gas. So that is already there are global warming potential and all. This has very high global warming potential compared to CO2, so which is considered the major greenhouse gas. Solution cases, we are segregating at source, and then it is collected, reused, and it is the biodegradable waste may be sent to the composting for the composting, and sanitary landfilling is done only for the non-recyclable, actually inert material. As per the definition, it should be only going the inert material, so we can in fact eliminate the generation of methane gas. So it has health impacts, can cause direct and indirect impacts. So we are inhaling the air. So there are several like methane and other gases will be generated. Also, there may be bioaerosols, which we do not talk too much about that, but they may also be in the environment. And environmental impacts like this is soil, water, and air. These all are our natural resources which are contaminated by the unscientific disposal of waste. Now, this is actually the waste hierarchy as per CPHU. So they are at source, reduction and reuse, so we can minimize the waste generation when we are using carry bags and all. Recycling is the processing non-biodegradable waste to recover commercially valuable material. So when we are doing for paper, metal, glass, or paper, like it is sent back to the pulp and paper industries, where we again produce paper from the from the waste paper and all, right? So here the composting, earlier in our this waste hierarchy, composting was the part of recycling, but now it is actually the third this thing. This is used for the organic waste. So actually both are on the same tier, but they have actually in CPHEO, they have kept this recycling for the non-biodegradable waste over the composting process. And then this is waste to energy. So this is waste to energy is where we are producing this diffused dry fuel, which is primarily contains the combustible fraction of municipal solid waste, biomethanation or anaerobic digestion, which is done for the organic waste and co-processing and all. So, and finally landfilling. So though waste to energy is the penultimate option, but it's still actually now it is considered an integrated part of any waste management strategy. So that is integrated waste management strategy in any city. It is considered as one of the part because the waste which cannot be composted or recycled and it has some calorific value, then it should be used for the recovery, energy recovery, and co-processing when we can send this material to the energy intensive industries and all. So, madam, you please tell me the time, right? So that is, I will flip.
Sir, you can just wind up in 5 minutes.
Yeah, fine. Thank you. Thanks. So these are the major processes. So where waste processing method are biological. So composting, you can produce compost, anaerobic digestion, biogas. But digestate here, disposal of digestate is a major issue, right? Generally, if you will talk, then you will say that digestate is rich in the nutrients and all, and it can be directly used for the as a nutrient. But that is actually, if you look at the process, this is an anaerobic process where this reduced compounds are formed. So basically, before using it as a fertilizer, we have to stabilize this. Otherwise, it may contain some toxic materials which will actually harm the agricultural fields and all. And these are the thermal processes. I will not go into this. So this is some composting systems. So we are working on this also. So we are developing some composting systems, and in fact, we have filed patents on that also. So this is actually this is a composting system, is small scale, where 2 to 2.5 kg per day waste can be treated. So it's a very small, like 4 apartments are there and all. So for that, it can be used easily. And there are compartments are there, and then its cycle time is 30 days. Like 30 days, we can produce a good quality compost. Now, I am just telling so very briefly about the plastic. So the plastic we generate very less, but it may also increase. It is only 11 kg in 2014-15. 11 kg per capita consumption in comparison to other countries. So around 60% of plastic is recycled. So Delhi generates very large amount of plastic in comparison to the other developing nations. So now I am coming. So what can we? So these are different types of plastics. So PET, HDPE, high density polyethylene, PVC, polyvinyl chloride, and all that you can see here. And so what is the actually there? How can you use them? So first thing, see that we should discourage the use of single-use plastics, minimize buying water in this like plastic bottles and all. So, but how can you do nowadays? Actually, there is like some municipalities have made mandate. In fact, especially in Maharashtra, it is preferred to use plastic as the road construction in the road construction. Right? So there, in fact, there is a lot of opportunity of recycling plastic in such a manner, because burning, otherwise plastic has good calorific value. If we are burning it, then environmental emissions are quite high. But if we are recycling in this manner, then we can suppress several a large amount of these emissions and all. So that is the benefit of this. So this is one of the major ways for recycling the plastic these days, right? So this is compostable plastics are also gaining attention nowadays, right? So that we could compost them, but there is a disadvantage. If there is dye and all are there, once it is biodegraded, then these toxic materials are also exposed to the environment, and then actually they may have impact. So anyway, this is something that we should look into, right? So these are the things. So I will stop here. So thank you very much for your kind attention.
Thank you so much, sir. This was such an informative session on municipal solid waste management and what we as stakeholders can do for managing this waste. I believe all of the participants, they must have, this session has enhanced their awareness about acting responsible and thinking sustainable. Thank you, sir, for taking out your precious time and connecting with us here today.
Okay, thanks a lot.
Thanks a lot, sir.
Thanks a lot.
Thanks for coming. Thanks for your talk. We'll be happy to connect in future as well for different programs. Thanks.
Yeah. Sure. Thank you very much. Thanks.
Thank you, sir. So now we have Professor Sumedha Chakma with us here today. A very good afternoon and a very warm welcome. So Professor Sumedha Chakma is working as Associate Professor and an expert in watershed management, bioreactor landfill and permeable reactive barrier. He has joined at IIT Delhi in 2014 as Assistant Professor and actively involved in teaching, research, consulting, and also in administration. His current research interests include settlement, gas, and leachate generation in landfill, infiltration study on different land use and soil type, land cover and land use change in watershed, groundwater contamination and remediation, and development of new materials for permeable reactive barrier for different contaminants. Further, Professor Chakma is running research projects that received grant from Department of Science and Technology, Government of India, and FIRP from IIT Delhi. He is involved in administrative duties as Warden, Program Coordinator of Water Resources Engineering, and was also in charge of President of Dramatics Club. He is also participating in table tennis games and received the Most Promising Sportsman Award in 2018 on Republic Day of India from IIT Delhi. With this, I warmly welcome, sir. So I invite you to share your enriching experience with all of the participants who have connected with us here today. Over to you, sir.
On behalf of IIT Delhi, I would like to extend my thanks for inviting me, especially Professor Parul and other IIM members. And thank you very much for my introductions. So shall I start? Okay.
Sure, sir. Please.
I think my sharing something is okay. Just let me share. Yes, the sharing button is not coming. I don't know.
Arpita ma'am, can you please enable that sharing?
Sir, will you be able to share or else I should do?
Yeah.
Because I am starting my screen as you shared this PPT with me.
Okay, you can also share. I can also, whatever if that's fine from your side. If you want to control, that's fine. Yeah. Yes. Yeah. Yes. Next slide, please. So as you know, this is a very important topic these days, solid waste management. Yeah, we are spending a lot of money, but still we could not able to see the outcome, why that is happening, what is the ways we can solve. This is the right ways. I think if we discuss further, then only it is possible to solve these recent, again, upcoming, although it will keep on going on this process. So why, can you please share next slide? So I'm working as, Madam said, that 3 areas, watershed management and that contaminant hydrology and this, your reactive, I think slides are not moving. Yeah, I could not able to see.
So just a minute, I am also, so it's fine now?
Yeah, but yeah, can you, it means full screen mode if you don't. Yeah, next, if you go next one, but it's coming small, yeah, yes. Apart from that, yeah, I'm also working on this solid waste management, mostly doing mathematical modeling. We want to really check how the various changes would take place. Like we have a major problem with leachate, like we have 17 inactive landfill in metro cities like Delhi itself. Can you imagine what is happening throughout India? So what is happening from there? Leachate, which that generates due to biodegradation, and since we don't have any liner or any collection system, as a result of that, it's directly going beneath the water table and joining, and this groundwater table is getting polluted. So we really need to think for our next generation the way the groundwater contamination is taking place. I hope you can go next slide, please. Yeah. If you, okay, you can see the scenario in developed countries, 1989, it's long back, they tried to reduce these landfilling like 68.8%. We tried but still we are struggling. Some although suggested that we could able to reach near about 60%. I doubt. If you see small cities, most of the ways they are just throw in the low-lying areas, which is not happening in real life. On paper might be happening, but in real life you can't see. So that should be target. We try to reduce as much as possible to put those waste in the landfill. But what is happening? That is not happening. We have 3 active landfills in Delhi. I think they're supposed to close long back, but still over flooding. And if you see the Delhi's generation in 922 tons per day that time, and it has been double now. It's not near about 11,000 tons per day that production is taking place. And similarly, 400 gram, now it has gone near about 800 gram. Average near about 670 gram in India. But if you see, it's getting double within 20 years. So I hope the rate is going to furthermore with time, because cities are growing, development is taking place. More development means more waste could generate. So we need to really plan well. Otherwise, there will be air pollution will be there will be ground pollution will be there. What need to be done? So you can live, but you cannot drink contaminated water. If you drink that contaminated, your longevity will definitely come down, right? Many diseases would be cropping up. So next, please. So another major problem is the settlement. So if we construct the building, anything, after the post closure of landfill, what is happening, right? The settlement is taking place as a result of that failures. That few years back, there was a failure in Delhi itself, elsewhere. The one area that came out. Similarly, Sri Lanka, Italy, in the developed countries also. Why that is happening? We are unable to predict this settlement because it having various type of waste, not only one type of waste. We generally consider one type and then doing the mathematical modeling. As a result of that, we are not predicting space. We think that like in Delhi, we thought that would be 3 landfill would be sufficient, but that is not happening. Why that is happening? Capacity. We could not able to exactly calculate the capacity of the space. So that this degradation we really need to calculate accurately. So as a result of that, the failure you can see in the most of the cities, most of the metropolitan cities, we are over flooded with this solid waste. Yeah, next, please. Similarly, this you can see the leachate ponding that is at Okla landfill. What is happening? There, the whole in low-lying area water is, and if we could able to see, because there is beneath it as a rock layer, that's why we could able to see. And if there is suppose no rock layer, no layer, so it could have percolated directly beneath the ground and could have contaminated. That is happening in I think elsewhere areas, whole area that has got contaminated. You cannot drink water at all. That is really so. What need to be done? We have 17 inactive landfill in Delhi itself. What need to be done in those areas? So you cannot drink water. Really, we are polluting water for our future generations. So immediate measures are required. So some of the areas like more than 26 hectares areas are there where we don't have anything. Similarly, another major problem, as you know, from the landfill, this methane emission that is taking place, right? We don't have any good system where we can able to capture. Why that is we are failing? Because it has been said that cost that if you want to capture and methane, if you want to for installing those so expenses are more. We really need to design new system where you would able to do the cost cutting system. Otherwise, what is happening is if you go those areas, you can always the fire is taking place from those places. Nothing, no captures. We are trying, although in Goa, in one Okla landfill, but what about the others? Many cities we are not capturing at all. So we need really require to capture these methane gas, because if you release these, these global warming that will take place, so climate change would take place, many more, okay, temperatures goes up. Oh, that's again dangerous. So that's again concern from my. So what we can see that which has a carbohydrate, protein, fats in that. So I have modeled that system, and if you're able to capture these methane, then really good, not only good, but what system would be required? System would be required your low cost system, right? Like our developing countries, we cannot go for your developed countries, but we did that in 1980s, right? We have gone for incinerations, which the technology brought from Germany, but that plan failed. The reason was that their temperature or weather system is not same at all. So if you want to copy directly from their system, you are going to fail. This is the major concern. That is, we are just adopting their technology. We are not going ahead what is happening at local level. So even if I want to implement the technology in say Shillong, Meghalaya, it won't work because the climate system is not same. Temperature is not same, right? Your land cover is not same. So you need to really design separate way. And okay, so this is some few models how. So it has, we can see that we can able to capture near about 20 years, okay, 20 to 30 years better, but beyond 30 years, yeah, it's not practically good. So if we can capture these gases 15 years very well as per the study. And then if we, but the second important is that how to design that. That's the next, which is not yet done as a result of development is not taking place. Next, please. So if you see the components, it has a biodegradable component, inert, recyclable component, and this component keep on changing. They are not same. If we measure this 2020 plastic component, that is going up in Delhi. So scenario that is changing. So we need to really analyze, characterize regularly, and then only we can evolve correct methodology, correct techniques, correct technology. So why we got failed in Delhi? We got the technology from Germany. Why we failed? Because we having inert material. You can see that 35% inert material in Delhi. That's why that plan, and we had incurred near about more than 100 crores in Delhi. And yeah, so we need to evolve with respect to the development that is taking place with respect to solid waste. So if you see the waste component, so earlier mostly people thought about this moderately and rapidly. They never ever thought about the solely biodegradable, right? And also they could able to put non-biodegradable the solid waste. This is the concern. Next concern is they have taken as a constant density. Density means it won't change with time. If you measure the solid waste, if you put it in the landfill waste, it says that okay, same density would be same, which is totally incorrect. So that way, if you go design that way, your system is going to fail. So you can see that these various components keep on changing. So with respect to this component, you need to really evolve your technology. If we don't evolve the technology, obviously we are going to fail. We won't be successful at all. Yeah, next, please. So if you see the constant and that variable density, so I could able to find out what differences could be there. So settlement itself, you can see the quite big differences you'll be finding, right? And similarly with respect to pH and others, there will be big difference will be as a result of that. What is happening? We are unable to calculate the capacity, actual capacity of those landfill when we will be getting the exact that how much capacity would be generated with respect to time. So that's the reason we just make it with all the calculation based on the constant density. We really need to change that density is not constant, density is variable. So this is the one component. You can see that the settlement cell gave quite big difference if you take the constant density. Right, next one, please. So again, post-closure settlement. So we never ever thought earlier that settlement due to biodegradation, mostly settlement was calculated based on mechanical compression as a result of failures that took place around the world, right? And now only slowly the component, another component, this new component settlement due to biodegradation that is adding up. As a result of that, we could able to find out the actual capacity. If we neglect this settlement due to biodegradation, then we won't be calculate accurately the space, how much that would be generated with time. So earlier we were just putting the mechanical compression. Again, density in the mechanical compression, we are taking the constant. So just we had developed this your mathematical modeling. So we could able to see that if you constant, so your stress that will be totally different. If you take again variable, it would give different results. So stresses, again, similarly from stress, you can find out settlement, you can find out volume, various components. You can find out. You can design your landfill. Yeah, next, please. Okay, this is just again, yeah, same. We need to take care of this. Again, just simple. You can see that this, if you take this pH also, simply I took this pH in the model, so you can see the differences. So if you take the pH settlement again, that is more. So you really need to take care of this pH, your temperature, this moisture content. Otherwise, you won't accurately calculate the space. That's what is happening. We would be otherwise flooded with the solid waste. Yeah. So with respect to that, again, we had gone through why we are not calculating accurately. The observation that has been found that most of the testing that was done taking as circular sections. Okay, we do experiments in the circular section and try to find out the size of landfill with your trapezoidal shape. So as a result of the calculations, don't give accurate results. So everywhere that failure was taking place in the era. So we got the patent in 2002, and this new design, this trapezoidal shape, you can see you can see on the left hand side or on the right hand side. Yeah, circular. Most of the your experimental study were carried out by your circular section. That's it. We really need to do the experimental studies based on actual how you are putting your waste, whether in a circular type, whether in a trapezoidal type. You need to consider while doing even experiments also. That's our finding. Yeah, next, please. Yeah, with respect to that, we also gone through, sustainable, as the name itself, we have mentioned, that's very, very important, right? So how we able to achieve sustainability, right? So sustainability can be achieved whether we should go for pre-treatment of waste, then we should send these waste in the landfills, or without pre-treatment, we should directly put in the landfill. So we had gone through various these reactors. The 4 reactors, you can say. Apart from that, those reactors, one we have especially kept your circular sections to see what differences. From there we could able to understand that whatever the calculations we are doing, all the calculations are incorrect. So the correct way to the calculation, we need to really reshape our design. Then only it is possible to correctly calculate our design. So apart from that, we could able to check also these your waste, like whether these wastewater would be good, gray water would be good, like your tap water would be good, right? Potable water would be good. So we found that it's, if you put wastewater in this your waste, you can see that this experimental study, one PhD has been achieved from this your various reactors. So we could able to put in the ambient temperature. That's again main concern. If you do the experimental study in Germany, and if you say that these are the results, it won't work. Totally different. So we could able to see that the gas generation that takes place, okay, once the temperature goes, say beyond 19 degrees. So below 19 degrees is minimum. Is you won't able to generate, or you won't able to get this methane. So no use. So if you are going for any plan to capture this methane in cold climate, you won't be successful. That's what is happening. Failure is taking place. So others, you can see that various components, your BOD, COD, everything you can come down. What we were doing, like we were recirculating this waste, leachate, whatever leachate, as you know, this biodegradation that takes place because this moisture interact, and as a result of that, degradation takes place and leachates, and then when leachate that do not generate, then we added this wastewater, gray water, tap water in the system. And what we can see that your BOD at the end of 270 days, or those all results. But previous slide, please, previous slide. Yeah. You can see that, although from my side it's not visible, you can see that your BOD is 11,000 and it has come down to 50. So if BOD is high in your leachate, in your water, that means aquatic life is danger. All the oxygen it will take away. So you cannot release that water to your river, right? That's that is very good. We could able to achieve 50. At your on 6 to 70 days. Similarly, we could able to see that this municipal solid waste, industrial waste, also they are mixing. So some northeast area, okay, they were mixing with paper mill waste and putting in the low-lying areas. So really thought came to mind, what would happen, okay, if we really combine this waste? No study took place around the world, and we at IIT really could establish this kind of study here, mixing paper mill waste, industrial waste with respect to the solid waste. What the changes of various behavior takes place. We got fantastic result. Madam, can you please next slide? There is. Yeah, we got fantastic result. Yeah, so in one reactor we put just simply municipal solid waste. Another we have put 50% your municipal solid waste. Then we put your two types of waste. One which is known as your effluent treatment plant sludge from the paper mill, and another is, you can see, R3 linking plant sludge. So 50% we have combined and mix, and could able to find that gave very good results. You can see these municipal solid waste, whatever. So three kind of waste we have combined with only municipal solid waste, no other waste, and got very good results. So it gave much more that what we never ever thought. It gave higher gas productions. Yeah, right. It stabilized the system. Okay, settlement. Whenever you took that one municipal solid waste, that settlement is more instantaneous settlement, that more. But wherever on the other hand you got the settlement that was coming gradually, that the differential settlement into place. So most of the failures around the world, why that in the landfill that is taking place, differential settlement that happens, we are still not able to measure these differential settlement. Although we could have able to measure mathematically, but yeah, on the field, no such record are available. Yeah, yes, madam. Next. I won't be taking much time. Next slide, if you. So next, I was talking about the leachate. What needs to be done in that? Okay, to stop, because groundwater contamination is taking place. This is the way through which we could came up this reactive barrier, so which is known as permeable reactive barrier. So we need to, if you design this reactive barrier and properly install that, in that way we can minimize these pollutions. But what is happening on the other side, you can say a treated side, your residential areas, landfill areas, all water is going towards that area. So unless we do this PRV, no other ways. Otherwise, what is need to be done? Pump and treatment technology, which is again highly expensive. Again, you need to monitor regularly. Yeah, just you need to put this your PRV, whether one PRV would be good, whether another second PRV. If second PRV is not good, you can go ahead third PRV. That way, we can protect our this groundwater. In the I think conclusions, what I would like to I would like to say that this your prismoidal say bioreactor landfill that give higher stability, and if you consider this circular shape from the study. Similarly, if you do the pre-treatment, so very good. Again, whatever the if you directly waste them on the landfill area, or if you do the pre-treatment and then you go for landfilling, then it has been observed that it gives near about 3 to 4 times higher than your dose without treatment. Similarly, if you put industrial paper waste further, again it goes much higher, 5 to 6% higher for your methane generation. So similarly, stability, we could able to see that stability also better in the landfill system. Most of the failures that takes place, stability, they are not stable. As a result of that, that's got failed. And at the end, what I like to emphasize is that we need to really encourage this bioreactor landfill. Why that is required? Because we not only manage this leachate gas generation, we also can develop the space with time. So if you want further degradations, okay, we can recirculate this leachate, recirculate wastewater, various way we can enhance the system. But if this traditional landfill, what is happening, we are unable to enhance the degradation. That's the drawbacks. So at the end, I'd like to thank you once again to all. And if you're having any queries, most welcome. So I am on time.
Thank you so much, Professor Chakma, for this informative session and for showcasing all of the participants who have connected with us here today, what is actually happening and what really can be done, and showcasing all the treatment measures that can be undertaken. So thank you so much, Professor Chakma, for connecting with us here today, and definitely in future too, we wish to connect with you. And all of the participants here, I believe all of us and all the participants, they have had such an enriching experience by hearing to this particular presentation. Thank you so much, sir.
Thank you, Professor Porul, for giving me opportunity to talk with all of you, and good day to all.
Thank you.
Okay, so may I leave?
Sure, sir.
Okay. Thank you very much.
Once again.
Thanks a lot, sir. Thanks a lot, Professor Chakma.
Okay, thank you, Arpita madam. Thank you.
Thank you. We'll have some discussion if we can collaborate for this project for solid waste management in future. Thank you, sir.
Yeah, definitely. Yeah, many issues.
I'm also pass out from IIT Delhi.
Yeah. I have seen your when I got through.
Yes. I did my PhD with Professor Sri Krishnan and Professor M.G. Dasidhar. M.G. Dasidhar is retired, but Professor Sri Krishnan is there.
Yes. So nice.
Yes, sir. Thank you, sir.
Okay. Hope to see you once again. Yeah. Bye. Take care. See you. Bye. Thank you.
You too. Thank you, sir. Over to you, madam.
Just a minute. So I am making Mr. Joshi as presenter. You can introduce her. Thanks a lot, Mr. Joshi. Are you there?
Yeah.
Should I go ahead, ma'am? I want to give a warm welcome to Mr. Jayant Joshi, Group General Manager and Head, Environment, Water, Safety and Sustainability at Engineers India Limited. His experience spreads over 27 years and is a competent professional and environment practitioner with experience in the oil and gas industry, power sector, non-ferrous metallurgy and infrastructure project. Mr. Joshi is also a certified EIA coordinator and functional area expert. The experience includes preparation of EIA report, feasibility studies, design and management of solid and hazardous waste, water and wastewater treatment plant design, development of pollution prevention strategies, coordination with local authorities, planning and implementation of environment management system. With this, I want to invite Mr. Jayant Joshi to share his experience with all of the participants who have connected with us here today. Over to you, sir, and a very warm welcome. And thank you for joining with us here today.
Thank you very much, Dr. Parul. And thank you, Dr. Apita. I think it's my pleasure to be present here on this seminar of the national importance, I should say, because sustainability is everybody's issue in today's scenario. I have been in this field for the last, say, 34 years. And right from the beginning, I was involved in almost all types of activities which are related to environment issues. So today I thought I will give a presentation wherein basically the emerging technologies which are prevailing in water treatment in oil and gas sector should be presented. So I would be giving you my details, technological details about this. I'm unable to play this. I don't know. Excuse me.
Sir, is the slide not going forward?
Not moving.
It's not moving.
No.
Arpita ma'am, can you please have a look in it? Arpita ma'am, am I audible?
Yes. Ma'am, actually, Mr. Joshi is presenter right now, so I don't know what's the issue. Sir, can you please make the screen a full screen first? Then you can.
I'm trying to do that, but something is not happening here. Just a minute, please. Give me 1 minute.
Full screen, and then you can control it from there. Or else you can mail us your PPT if we can share the screen.
Just a minute. Give me 1 minute, please.
Sure, sir.
Because when I'm going to my screen, it is not showing anything.
Okay, sir.
It is there. Your screen, first screen is there.
This is I took it from the file. This is not the one which is basically but it is not moving.
So, sir, please share content. Have you done the share content things?
Yeah. We have been
Okay.
doing this.
Then you just forget everything. Just open the PPT. First slide.
Actually, it's not moving.
So
My
from
screen is
top.
not coming. Problem is this.
Yes.
So what to do?
I will again do that.
Yes, so if you can close this and again share.
Share your desktop screen, then you can play your PPT.
It is not moving. Just a minute. I will stop sharing, then we'll do that.
Yes.
The option of stop sharing is not coming here.
Okay, sir.
Should I send you the slides?
Sure,
Yes, sir,
sir.
please.
You can email Dr.
I will do it to you,
Arpita.
Arpita.
Yes, yes.
Yes, sir.
Hello.
Hello, yes, sir.
Ma'am, have you received
Madam, I
this?
mailed it to you.
Okay.
You will be getting it.
So probably I do not have this right now. I am Sirmaur host. Rijuanji, are you there? पारुल मैम आप एक बार कॉल कर लीजिए रिजवान जी को मैं पीपीटी देखती हूँ
ठीक है मैम. Have you received the email sent by sir?
No, till now not. Probably it is getting uploaded, but I have lost the right to make myself presenter or someone else presenter.
Okay, let me call Rizwan. So we are so sorry for the technical glitch. Please give us a moment.
Sorry, sir. Just a minute. Till now, not, sir. Mr. Joshi, till now, I have not received your PPT. Actually, sharing right is with you, Mr. Joshi. And probably I cannot take if you cannot close it.
Sir, are you able to move the PPT now? Hello, sir, am I audible?
Yes, yes.
Sir, you are able to move the presentation now?
No, no.
No. Vipinji, sir is not able to move it.
See, normally when I go to my screen, I get, say, this, my presentation, but it's not getting.
अच्छा, left side में icon है. कहाँ पर click करें sir left side में? अच्छा, sir, can you see the zoom in and zoom out icons?
Yeah.
Left. Zoom in के ऊपर एक icon होगा sir, उस पर आप can you click?
Yes.
Now you can move your.
Okay.
Yes. Okay. Thank you, Vipinji.
Thank you.
Yes, sir. Yes, sir.
Should we go ahead now?
Sure, sir.
Okay. So the presentation which I am making today is about the how do we do the oil exploration, and from the oil exploration when we produce water, how we take care of that. What are the legislation which governs the oil, say, treated water quality, and what are the emerging technologies in the field of produced water treatment, and the various treatment options which are available right now. That is one part which I am going to describe. Second is the emerging wastewater treatment technologies part, only for downstream refining industry. And third part is the VOC emission control. How do we do that in our industry? My slides are visible?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So what is the produced water? Produced water is basically the water which we get when we do the exploration. If you see some of the pictures which I have shown, you can find out how the oil and gas are covered within a framework of sedimentary rock. And then from this rock, when we pierce down, the gas and oil, and along with that, the water, they all come together to the surface. And this is the water which comes along with the gas and the oil is called the produced water. Along with the produced water, we get a lot of chemicals also, because that chemicals we inject. So it composed of the dissolved and dispersed oil component. Then some of the dissolved mineral which is contained in that, some of the production chemicals which we add to it, and then dissolved gases like carbon dioxide and hydrogen sulfide, and then some of the produced solids. So this is what we get. And some of the components which are basically which are carcinogenic in nature, polar constituent like benzene, toluene, ethylene benzene, and xylene. These are the components which we also get along with that. And dispersed oil. Dispersed oil means the small droplet of oil suspended in the aqueous phase. And these are basically the component which makes the treatment much more difficult. Along with that, we get some dissolved minerals also, like we have got, say, sodium and chloride, which basically is responsible for the salinity, which ranges up to 3 lakh milligram per liter. Along with that, we have some radioactive elements also. Radium is also one which is present in different, say, elements like 226 and 228. So these are all the product of the produced water which we get. So how difficult it is to treat, we'll come to know later. Because when we explore oil, we also pour some production chemicals. These chemicals helps us in attaining better oil recovery. And some solvents are also added along with that. So these also comes along with the produced water. Some of the inhibitor, corrosion controller, scale reduction chemical, form reduction chemical, they also come along with that. So it's a basically cocktail of every activities which we do during the exploration of a field. Now, it is not restricted to that. We also get some clays, precipitated solids, waxes, then bacteria, carbonates. So a lot of things you get along with the produced water. So produced water is the first one which we have to treat when we are exploring the oil. And the important part of this is the gases which are there. Some of them is highly, say, toxic in the sense that hydrogen sulfide, when it comes, it is not in a small quantity. It's a very large quantity of hydrogen sulfide because of the nature of our wells. So these have to be taken care because hydrogen sulfide normally, when it comes in contact with the water, it basically creates low pH, which is harmful for the metallurgy of the system. Now, I will tell you, this is about the produced water. Now I'll tell you what are the legislation which are prevailing in the world. If you consider the Northeast Atlantic OSPAR, there and say the countries like Australia, Denmark, Norway, and UK, the maximum oil in water discharge limit is 30 ppm, which is dispersed oil. United States Environmental Protection Agency, it states that the maximum oil in grease can be 42 ppm with a monthly average of 29 milligram per liter. People Republic of China, they have laid a very stringent limit of 10 ppm and chemical oxygen demand 100 ppm respectively. But most of the oil and gas companies now in the world, they are looking for, say, zero discharge of the contaminant in produced water. It's very difficult to achieve, but people are trying for that. So what are the technologies which are basically we look for the removal of, say, these components? If you see the picture, we have got very large oil droplets, then small droplets, some dissolved matters, then coarse solid particles, then fine solid particles and charged particles. So these are the components which are present in produced water. So the first purpose is to give a pre-treatment where we can remove the large droplet and coarse particle and some aggregated particles, which is basically the required for the conditioning of water stream in the upstream process, which requires dehydration vessel and storage tanks, strainer, etc. Then comes the main treatment, wherein basically we have a primary treatment which is required for the removal of oil droplets, small oil droplet particles, and secondary treatment we give, wherein we can remove the more larger, say, more smaller droplets of particles. Then we have a polishing, wherein basically ultra small droplet we remove, which is for the final cleanup, which is required when we need injection in the well to enhance the recovery. And sometimes we also need the tertiary treatment, wherein basically we need to go for very low hydrocarbon containing produced water so that it can be used for tertiary requirement, wherein basically the biological treatment also sometimes given. So these are the steps which are required for a produced water. Now, what are the processes which are used? That I will let you know. Some of the technologies which are prevailing in the world, they are basically of three types. One is mechanical, other is, say, adsorption type, and other one is the hybrid type, combination of these three. So mechanical type means you will have gravity, enhanced gravity and gas rotation system and filtration system. Adsorption type means you can have activate carbon, walnut shell filters, and microprocessor polymer extraction system. And hybrid means a combination of these two technologies. Whatever technology you are going to choose, the basic purpose of this is that it depends on the objective of the produced water, but you are going to go for that. Means if you want to reuse the water, then you have to have a altogether different system. And when you want to dispose it off to the sea, then altogether different system. Suppose if you are going to recover the water and reuse it, then you may have oil less than 5 ppm. And you may also have the suspended solid less than 2 ppm. And then the dissolved gases should be less than 10 ppb. More often we see that sulfide reducing bacteria count is also important in that case. And then you have a desalination requirement also, because you need to control the sulfate in the produced water so that you can re-inject it. And the removal of naturally occurring radioactive substances, we call them NORM substances. And sometimes you need the effective polymer flooding to improve the performance of oil recovery. So these are the basic objectives based on which you design your treatment system. Now, what are the treatment options available to you? We have been using in the industry right now the hydrocyclones, gas flotation system, adsorption system, media filtration system, some ecotech spectrum system, then microfiltration. But some of the recent trends which I'm going to present you is some new technologies which has come up, like macroporous polymer extraction technology, then advanced oil coalescing and polishing technology, then CTOR technology, and the latest one is zeolite, IF and ultra EC technologies. So these are the latest technologies which are in use and which will be deployed in the industry. When we talk of macroporous technology, this is a technology wherein we go for the liquid-liquid extraction. Like in that, extraction liquid is immobilized in microporous polymer particles. Like you have a polymer particles in two of the say tanks, wherein you say absorb them and then continuously pass these streams through them so that they can absorb it, and then whenever a particular filter is exhausted, then you can exchange it. That is basically the macroporous polymer technology. Second one is advanced oil and coalescing technology. These technologies are basically a very compact technology wherein basically 2 or 3 stages can be grouped together, wherein you can remove the free oil, emulsified oil, as well as some of the oil which you cannot remove through normal IGF system. Other is the CTOR technology. CTOR technology is basically it relates the principle of wherein the produced water, the solvent which you get out of it is re-injected so that you can have a bigger molecules available of the oil droplets, and then you can even enhance the recovery. This is based on this principle, and the oil droplet, which is basically the now bigger in size, can be mechanically separated. The last one which I'm talking about is basically the pH control system. Zeolite IF Ultra EC, where this is basically consists of pH control settling tank and zeolite chamber. Here the zeolite chamber is a special zeolite which takes care of oil and even the other components which are present in the produced water. And then you have a induced air flotation system for further removal of fine oil globules. Then ultra EC for any COD and BOD removal. Then you have got a pressure filter into it, carbon filter, and you get a very good quality of water after this. This is one of the latest technology which now comes the. This is already I have explained. Some of the technologies which I'm going to present you today is the emerging technology in the wastewater treatment. They are basically the electrolysis. We know about the electrolysis, but these can be used in a cooling tower which we have in our refineries, where we can increase the COC by just incorporating, say, the blow down into this COC in this cell, wherein we have got a electrolysis process, which basically removes the hardness of the water, and this hardness helps in removals helps in improving the system, and it basically removes the hardness of the water, and thereby COC of the cooling tower improves a lot. Then other technology which is now is very much on the verge is the graphene-based absorption system. In the graphene-based absorption system, you need not to go for, say, one stage or two stages. It is a system wherein basically the graphene itself take care of oil and ultra small oil droplets. And then in one stage, you can have the complete treatment. Then you have got the advanced oxidation process. This process basically what we have recently done for some of the refineries. We found that the nitrogen was a problem in the refineries, and whatever treatment we were giving, we were unable to control the nitrogen. So we have gone for ozonation and electrochemical oxidation. These are the two technologies which really help in controlling the nitrogen in the industry. Then electrocoagulation. This is a very, it's not a really recent technology, but we have started using it for the, say, one of the culprit stream which we have got in the refinery, like desalter effluent and spent caustic, wherein we can really take advantage of the, say, electrocoagulation and really, say, at a very small cost, we can treat in a very highly effective manner, which can control the dissolved solids, fats, oil, and other organic compounds. Then one more technology which we are, looking into the system is basically the non-chemical treatment, like using electromagnetic and electrodynamic field. This is basically taking advantage of, say, oil's, water's bipolar nature, and then using it for the purpose of, creating electromagnetic field between two sources. And then what happens in this case, we develop some seeds which are basically the calcium carbonate in terms of argonite form, and argonite doesn't stick to the surface, and that's the advantage of this. And along with it, you can remove the bacteria and other components also. So this technology is also very good, and we have been using in the field now. One of the technology which we have looked really into is because zero liquid discharge is the latest norm in the industry, and without considering the existing system like your evaporator and crystallizer, this technology is slightly different in the sense that we take advantage here of the vacuum, wherein we create a small stream where in our evaporator we increase the efficiency in terms of removal, create more solids, and then in single stage we are able to remove sludges and then concentrate water, and then whatever heat is produced we are able to recover that, and we are not using any external sources except the thermic fluid heater which we need for this. And even we can have the photovoltaic gas solar concentrator for that purpose, wherein we can generate the heat and then reuse it in the evaporator. So this is another technology which are on the verge. Another system which we are thinking it can help industry is the solar evaporation using, say, the solar concentrator, where you can evaporate the water, and then whatever using the sun's energy, and whatever is left out in the evaporation, you can evaporate it in the open pond, which can. So these all are the technologies which are basically very not energy consuming and very effective in nature. And finally, which another technology which I am going to tell you about, the hydrodynamic cavitation. This is a technology which can reduce, say, your scale, which can reduce your bacterial count, which can decrease your BOD, remove your oil. It can be used for all type of treatment. It can even further reduce your TDS. So we are working on this technology. We have got a patent on it, and I think very soon we will be coming up with a system which would help the industry in consolidating their position in terms of removal of all kind of waste in a very small footprint. Now, I would give you some brief about the volatile organic compound which we have in the petroleum industry. It is basically VOC, we all know. They are basically the organic chemicals which have very high vapor pressure at the atmospheric condition. And a VOC has a high vapor pressure and low water solubility, means if you expose it, if it is in water, you expose it to the atmosphere, it will evaporate, and having a boiling point in the range of 50 to 250 degrees centigrade. So this is the definition of VOC. Now there are different, say, directive. US EPA has different directive of what should be the VOC limit. European have a different directive. Something similarly, Germans have different directive. But as Indian, we have a, say, what we call, when we have a fugitive emissions, like from our storage tank, you should have a recovery of benzene and hydrocarbon around 95 and 99.9%. In our loading gantry, it is 99.5% and 99.9%. For xylene and toluene, it is 99.98%. So this is the fugitive emission as per Indian contents. Like, there is a requirement that when you are going for VOC in your ETP, at least 90% of VOC from the off gases, you will be able to control it. So the key factor which is affecting the VOC is the vapor pressure and how the VOC configuration is from where the water is coming to in your ETP. Then what is the surface area for which this water, say, effluent is exposed. And you will see that different say, waste which is generated in the refinery have a different type of VOC which you can consider, like cooling water system, your wastewater system, then solid and sludge. So these have a different these are the different sources from where you can get the VOCs. In ETP, we get in oil removal section containing of API, TPI and TAFs reactors, then biological systems, then oily and chemical sludge handling system, then wherever you recover the slop, that slop handling system, you will have all VOCs. So these are we have ourselves designed this VOC systems in refinery, and we device and scheme. If you see to control it, if you see the VOC which is expected in the various form in the refinery, so these are the components: propane, ammonia, benzene, then methyl. These are the various components. Go through it. Then important thing is basically the at the level which they are available in the refinery. Benzene can go up to 1800 ppm, toluene 470 ppm, xylene 150 ppm. So these are significant solubility in water. So what are the treatment options? Treatment options are many, but the most applicable which we have been using in the industry is the use of activated carbon, wherein basically we devise a system which is as per the requirement of say CPCB, and which is highly effective in controlling VOC in the refinery. So what we do basically, wherever we found that there is a source for VOC, we put up some nozzles which are basically sucking all these VOC which are emitting from these units. Then we have, say, detectors along with that, then some seal drums, some detonation arresters. So all these, considering all these things, we design our system. And then it compasses of many things like carrying pipes, wall side fans, flame arresters, carbon canisters, and a stack to take out harmless air from the system. This is what it is basically. If you see, if I just zoom it out, if you see, these are the units basically.
Mr. Joshi, sorry to interrupt. Can you please wind up now, means conclude now within
the last slide, madam.
Okay, thank you, sir.
These are basically the various units from where you expect that VOC to be removed. So the design of these nozzles, these are very important because you are sucking it here, and then you should know the air and hydrocarbon, when it is mixed together, they can create problems sometimes because of the explosive limits. So you should be aware of the what you are basically sucking it through a pipeline, and then you take it to a flame arresters, passing it through it, and then these are the all say carbon carrying filters, and then its design is slightly typical. So I'm not going to the design aspect of this. And ultimately, when you are releasing it, it should meet the requirement of the as prescribed by the EPA. So this feature should be cost effective. You should be able to control the various emissions. Then should have a predictable result and robust to VOC load variation, safe to use and proven technology. This is based on that we have designed system. I think I'm finished now. Thank you very much.
Thank you so much, sir. Thank you for sharing such an enriching presentation with all of us. And I believe all the participants who have connected with us here today have become aware about this produced water treatment steps and the emerging technologies in wastewater treatment. Thank you so much, sir, for connecting with us here today.
My pleasure.
Thank you once again.
My pleasure.
Thanks a lot, sir. Thanks a lot, Professor
Thank you.
Mr. Joshi.
Yeah. Thank you.
We'll be connected in future as well.
Sure.
So moving ahead, now we have Professor Brajesh Kumar Dubey with us here today. Professor Brajesh Kumar Dubey is an associate professor at IIT Kharagpur in P.K. Sinha Center for Bioenergy and Renewables. A very warm welcome, sir, and thank you so much for connecting with us here today. Professor Dubey received his PhD degree in Environmental Engineering Sciences from University of Florida, USA. Professor Dubey research areas include geo-environmental engineering, integrated solid and hazardous waste management, physical, chemical, and biological processes in natural and engineered systems, environmental nanotechnology, biogas production from waste, environmental risk assessment, site remediation, and sustainability issues, among others. Dr. Dubey is associated with various professional bodies, including Association of Environmental Engineering and Science Professors, International Solid Waste Association, International Society of Sustainability Professionals, and is a lifetime member of National Solid Waste Association of India. Dr. Dubey published a number of research and review articles in various internationally reputed journals in the field of environmental engineering and science, and have attended and presented research papers at various national and international conferences. Thank you once again, sir, for connecting with us. Over to you, sir.
Thank you. Good afternoon. You can hear me okay?
Yes, sir.
Okay. So just one more thing I wanted to add. I have started my career in EIL at Engineers India Limited. So seeing that EIL building was quite emotional for me. So because that's the where I I started my. So thank you, Joshi ji, for a very nice presentation. And I have just sent you a request on LinkedIn to connect as well. So we'll talk later because EIL is where it's like we all started our career there. We had a big group in '97. Okay, so let's come back. Let me share my screen. I don't think I have my share privilege here yet. Can you give me the sharing? It says I.
Yes, Arpita ma'am.
I don't have that right, ma'am. Rijwanji, are you there? I have messaged him as well.
Okay, let me give him a call.
So while we are waiting, I'll just start talking so that we don't waste time. So see, the topic I'm going to talk about today is on like a resource management, looking at how the waste has to be managed. What is the present conditions in India, global conditions, and also we will talk about some of the newer technologies which is there in terms of waste management. So my talk predominantly will focus on municipal solid waste. That's what I'm going to talk about. So let's see. So in terms of see, I think you had some lectures before as well. I think Professor Anurag Garg was here. One of my colleagues from IIT Delhi was also here. I was looking at the list. And then I think Madam from Sahas was here as well. So you must have got some basics of waste management already. So we'll talk about some of the newer challenges in here. But before we go to the waste management side, I'm just waiting for my slides here, still not here for my share privilege. So in terms of when we talk about these environmental issues, see, ultimately what we are trying to ensure is this planet is a safer planet for our future generation, isn't it? That's the whole concept. So what Josiji was talking about, or probably what the other presenters are also talking. And I'm sorry I could not attend earlier because right now I'm in US on sabbatical for a year from IIT Kharagpur, and it's pretty early in the morning, so I could not attend all the session. But in terms of still, it's not there. I cannot share yet. So in terms,
Give us a minute, sir. Something is there.
Sure. So in terms of overall, if you look at the environmental picture, see, always my first two, whatever is there in my first two slides, I'll just try to explain here. So some of you who have probably listened to me earlier may have seen that slide as well. I try to start with giving the big picture of why we are even talking about all these topics. So ultimately, the goal is to keep this planet safer, isn't it, for the future generation, so that we don't make this planet a much harmful place to live in, as we are doing it with all these different activities that we do. We have to have all these industrial activity, but at the same time, we need to make sure that we clean up our water, we clean up our air, we clean up our we manage the waste properly. So all those things has to be done, and this is because to keep our earth in a better place. So if you look at the age of this Mother Earth, it's almost close to 5 billion years. And in those 5 billion years, if you put that on a 24-hour scale, you will find that as humans, modern humans, we have existed on this planet for only 4 seconds. Because that becomes like 5 billion in 24-hour scale, gives us 1 second equivalent to almost like 50,000 years. So that 50,000 years is 1 second if you put that 5 billion in a 24-hour scale. So okay, now I'm the presenter. Okay, good.
Yes, sir.
Let me go.
Finally, I could not. Good.
Good. So I think you should be able to see my screen now.
Yes, it's there, sir.
Okay, good. So that's the title: Resource Recovery and Circular Economy Approaches in Waste Management. So as I was trying to, okay, this should work. Yes. So this was I was trying to say, that Earth is almost like 4.6 billion years old. Now, if you take this, some of the newer research suggests that it is even older than this, but we'll just say for our discussion right now, let's assume that this is the correct 4.6 billion years old. And if you take this timeline and put that on 24-hour scale, so that you get a 1 second equivalent to like 52,000 years. Because why 24 hours scale? Because we all are familiar with 24 hours time. Like we have 24 hours in a day, so we can relate to that easily. So in those timeline, you can see that there was like bombardment was there, Earth and the planet, they collided, and the Earth as we know today was formed, and nothing really happens for a long time. Then the bacteria comes in, they start producing oxygen, so we have excess oxygen now in the system. Then life starts coming up. We have dinosaurs, we have different species, but the modern humans, although Homo appears at 23:59:12, which is almost like 48 seconds, but the modern human comes at 23:59:56, which is like 4 seconds. 4 seconds is 200,000 years. So that's a long, long time. So in that 4 seconds, in that 200,000 years, we have created so much of waste that it's becoming, we have used so much of resources, and we have created so much of waste that it's becoming a big problem for today's generation, we can say. So and this problem has actually has multiplied many-fold in last 50-60 years. And after Second World War, with Industrial Revolution, with all these different types of industries, different types of products. In recent times, a lot of packaging, if you buy anything from Amazon, Flipkart, and all those different websites, you get your product, but it comes with huge packaging with it for keep the product safer. So those are also adding up to the waste stream. Recently, COVID had added another kind of a lot of newer type of waste, a lot of more packaging, more online shopping during COVID times. So this is creating a huge problem in terms of this waste that is produced. And waste is actually somebody has said that waste is not waste; it's a misplaced resource. Waste is a misplaced resource because it's the resource which we are not able to use properly, and that's why it is ending up in those landfills, as you see in big cities, like huge, like mountains of landfills. So how much it is out there? So this was a World Bank report done around 3 years ago, which was that world generates 2.01 billion tons of municipal solid waste. We're talking about municipal solid waste, the waste that I and you produce on a daily basis. That's the municipal solid waste. Any waste produced within the municipal boundary is municipal solid waste. And it says that unless urgent action is taken, the waste will increase to 3.4 billion tons by 2050. So that's what we'll have an increase of waste production. So what is there in the waste? So if you look at if you want to solve the problem, first thing we have to find out how big is the problem and what is the criticality, or what are the components of the problem. So in terms of waste management as well, we have to know what is there in the garbage. If I want to design some resource recovery approaches, if I want to design a waste to energy plant, composting plant, recycling plant, I should have a clear idea of what is there in the garbage. And in Indian context, it becomes very, very critical to know what is there in the garbage in terms of the waste which is coming to the treatment center. What has happened is many times we go to the individual houses and collect the waste sample and characterize it and design our plants based on that. But that is not the waste which ends up in the treatment system or the disposal system, because in the primary collection, there will be some of the rack pickers will take some of the recyclables out. We will have cow, goat, and other animals eating some of those organic matter. So if you're designing a compost plant, anaerobic digester, the organic fraction that you will get at your plant is actually way different than what was produced at the house level. And similarly, recyclables, a good amount of recyclables will be gone. Recyclable gone means waste to energy plant will also suffer, because most of these paper, plastic, they have good calorific value. So you need to have a realistic waste sampling as well. But if you look at waste in general, this is the global average. They have seen that metal around 4%, glass 5%, plastic 12%, paper and cardboard 17%, food and green waste 44%. If you add them up, that's almost close to 80%. So 80% of the waste can be easily resource recovered. because we have market for metal, we have market for glass, we have market for plastics, we have market for paper and cardboard. We can do also composting and aerobic digestion with food and green waste. So then what is the problem? I think you must have heard from Professor Gerk and other professor from IIT Delhi as well in terms of some of these aspects. So what is the problem here? The problem is essentially lack of source segregation, because there is no source segregation in place in most of the country. This piece I wrote in Economic Times again almost now 4 years ago, that for effective waste disposal, segregation is the key. So unless we have source segregated waste, there is no technology out there in the world, except you can talk about maybe engineered landfill, where you can dispose that garbage. So it's you have to keep, because see, we call it a garbage, but that's a raw material, isn't it? That's a raw material for any industrial activity, in any industrial process. So raw material has to be cleaner. You cannot have everything mixed together. You cannot have pieces of concrete. You cannot have pieces of bricks. You cannot have pieces of like street sweepings, like jhadu, after doing the jhadu, all the dust, everything mixed together and going to your waste to energy plant. That plant will not like it, and the efficiency will go down. So you need to have a cleaner material. And that's why the segregation is very, very important for any effective waste disposal and treatment technique. So when we talk about this resource recovery, we talk about all these aspects. There is a newer term these days. This is also not new, or like last few years now. There is a concept, there is a term of circular economy coming into the picture. Since many of you probably, since the program is done in Indian Institute of Management, so I thought many of you will be from management kind of background, so you will probably relate to this much more, like what is linear economy, what is circular economy. I assume that you are familiar with that, but very quickly I'll tell you anyway. So circular economy has a systemic approach where to economic development. We design it to benefit business as well as society and the environment. So these are, if you look at this business, society, and environment, that's kind of 3 pillars of sustainability, isn't it? That's when we talk about sustainability, there is a economics, there is a social, and there is environmental aspect. What is the economy today? It's a linear economy. What is linear economy? You take the material, you make product, you use the product, and you just dump it into the environment. It says don't do that. Let's have a circle. So circle means you have you get the material, design, manufacture, retail, use it, reuse it, reuse, repair, recycling, and then you bring it to the recycling sector, and then bring it back into the economy as much as possible. So try to go towards zero waste. When we say zero waste, we are not literally talking about zero. We are saying that let's move towards zero waste. So that's the whole concept of this circular economy, is to keep the material in use as much as possible and design out waste and pollution. Let's take the waste and pollution away. And so let's design the system in such a way so that waste and pollution never created in the first place. Now, I'll give you an example. Like if you have a marketing MBA, folks, it's actually it's for more targeted to you guys. It's a thing is that, see, when we design something, we try to make it look so cool. That's like we want to make it look so cool. So when you try to make something look really cool, at the same time you need to look at what will happen with that product when it is discarded into the environment. I'll just give you an example. For example, that fizz drink. That fizz drink was there, which is available in the market. I think Alia Bhatt used to do the ad for it as well earlier. I don't know who does it now. So if you look at the fizz drink bottle, that thin plastic is all wrapped around that bottle. Now it looks really nice. It looks really something new. When it came, it was probably one of the first kind of bottle that we saw. But think about the plastic recycling sector. Now that thin plastic has to be taken away, but that's a different material. The bottle is PET. Bottle is PET, which can be easily recycled. The thin plastic actually do not do much with it. But since it's all wrapped around, I need to really take it out. Now I need to have a separate system for that, isn't it? In the industry. So what is happening with that plastic bottle? Cannot be recycled, and it is ending up in the landfill. So we should design our product in such a way so that it's easy to recycle, easy to resource recovery as well. So we have to have a proactive approach rather than having a reactive approach. Right now we are having a reactive approach. When the problem is created, we try to solve it. we need to have a proactive approach where let's not create the problem at the first place. So that's the designing out waste and pollution. So reduce the release of greenhouse gas, less use of hazardous substances, less air pollution, land pollution, and all those kind of stuff. And this is already happening in many parts of the world where people are trying to have a holistic approach. These are the examples trying to give you a holistic approach of water or wastewater treatment, where we are trying to bring everything together and have an integrated system in place where we try to minimize the waste being produced and more resource recovery. For example, here, this is an energy factory, like anaerobic digester kind of factory. So the sludge from wastewater treatment plant comes here, food waste from houses comes here, and then the gas that is produced goes for electricity, goes for heating, and your fertilizer goes for like agricultural application, the treated wastewater goes here for the clean water, and then you can do phosphorus recovery and all those other recovery there as well. So try to have a plant which is holistic in nature, try to keep products and material in use as much as possible. So a circular economy favors activity that preserve value in the form of energy, labor, and material. So that's the whole concept. And you can do a lot of byproducts and all those kind of stuff. This is regenerate natural system. Again, let's not only protect but actively improve the environment. Can we design things in such a way so avoid use of non-renewable resources, enhance renewable ones, returning value, for example, returning value nutrients to the soil, using renewable energy as opposed to rely on fossil fuel. So there are things being done in terms of, say, waste management. If you look at waste management, circular economy, waste is there, biogas energy, green fuels, electricity production, biorefinery, recycling, all those things are happening. And similarly, we saw that for wastewater as well. So there is also a push nowadays to decouple natural resource use and environmental impact from economic growth, which is again, for many of you MBA folks, this is kind of important, that how to decouple nature. Like we should not keep on going to mines and creates a lot of mining waste, and then at the end of the day, after using the product, just dump it into the environment. Why not try to do the mining from the waste material? Let's get the waste the resource recovery from the waste material and bring it back to the economy. Why it is important, if you look at if extraction rate has almost like from in 2002 it was 7 billion tons, and 1900 it was 7 billion tons, and 2005 it was 60 billion tons. So, and all these leads to a lot of emissions, lot of environmental issues. You heard from EIL. EIL also does a lot of alumina refinery. In fact, one of the project I worked on was on Damanjodi, in Damanjodi and Angul, where we had the alumina refinery work going on. So when you look at all those mines, there is a lot of like environmental impact associated with that. If you look at the resource use from 1900s to 1905 to 2005, 4.6 tons per person per day, annually, to 8.5 to 9.2 tons. So that's also almost double. That means what? Why it increased? Growing population, economic development, increasing consumption, growing middle class as well. So, and that leads to increased resource extraction, greenhouse gas emissions, land degradation, water pollution, air pollution. So why keep on going on mine again and again? Why don't we try to use that product back? How can we protect the environment by decoupling, breaking the link between resource use and economic growth? So let's using less land, less water, less energy. So that's called resource decoupling. Maintain economic growth, using resource wisely over its lifetime. So that's what we need to do. And that is already happening. In Japan, they are in 2010, they were back to almost the 1970 levels in terms of resource use, although their GDP was almost similar or even better. But they decoupled, and they made more efficient processes, better use of the resource. Mexico City is doing that. So there is a huge market. There is a new kind of economy that needs to be created. We can call it a green economy or whatever, that needs to be created in this sector. See, people say that if you decouple and all that, what will happen? Like there will be no jobs. Yes, but we need to get newer kind of jobs, isn't it? We need to get newer kind of jobs and clean all our air, water, and soil, because and make the country as clean as any as like one of the best, you can say, some of the Western European countries which are much cleaner than us. Let's try to create jobs and make this country as clean as possible. We have to do a lot of things in India. 60% of the India's population will live in urban areas by 2050, up from around 30% today. 70% of the building that will exist in 2030 are being constructed or yet to be constructed. So applying circular economy principle, this vast amount of infrastructure, we can actually create a benefit of almost 76 billion US dollar, which is almost 5 lakh crore in 2050 compared to the current development path. So better urban planning, make livable cities. Now people are not talking about smart cities, they talk about livable cities. Because a smart city, unfortunately, what is happening is we think that just putting some cameras and Wi-Fi, that is the smart. You see, a smart city without having proper water, the best small city would be you can take your cup, go to any faucet, take the water and drink it. That's the smart city. Isn't it? Not just having Wi-Fi all around us. It's smart. So because if you don't have clean water, easily accessible clean water, having proper waste management, no air pollution, those are the smart cities. So that's why we are calling it more as a livable city now. India is getting urbanized. We already talked about that. And all these relates to the sustainable development goals. If you look at many of these here, for example, good health and well-being, clean water sanitation, sustainable cities consumption, industry innovation, affordable clean energy, life below water, life on land, all these relates to the environmental aspect as well. As I said earlier, we need a lot of resources in India. This is a projected figure, and some of you may have seen this report. This is how much metal, fossil fuel, non-metal minerals, and biomass will be required in India by 2050. Up to 2010, it's the actual figure, and 2010 onwards, it's a projected figure. So as you can, the future needs for India for resource, and we need lots and lots of resource. So we will have, our challenges is the resource availability, access, affordability. So we have to have resource efficient process. Use of secondary material is inevitable. Secondary material is the material coming from the waste. Different types of waste. I'm talking about municipal solid waste, but we have variety of waste out there, agricultural waste, mining waste, all those different types of waste. We have to do resource recovery from there because there is no other option actually. We have to go that way now. So in terms of solid waste, this is the problem in the solid waste sector is that collection is not being proper. Only about 70% gets collected. Even of that which is collected is hardly 30% is getting treated, and rest all are going into the landfill, dump sites basically, not even the engineered landfill. So we have been working on waste management for a long time. Don't worry, I'm not going to bore you with all this regulation, but I just wanted to show you that there is a huge amount of effort has gone into regulations and different types of manuals, different types of stuff in Indian context as well. The problem is not of the rules that much. Problem is not of the technology also that much. Problem is more on management in nature actually. It's more of taking these things on the ground and making it work on the ground. It's more of an implementation problem rather than I would say, and having a holistic approach and doing proper implementation. As I was telling you, having a proper waste characterization, doing a proper waste sampling. So those are the things which needs to happen on the ground. So in recent times, there are a lot of effort to make the rules a little bit simpler, but still our rule is we have one of the strictest rule in the world, and without having proper infrastructure to support those rules. So we need to have proper infrastructure as well, which can support those rules as too. So whenever we go for an integrated solid waste management system, first of all, you need to identify the need and look at what is the review existing system. So you cannot reinvent the whole system again and again because budget is always limited. You look at the existing regulation, you come up with like a decision-making framework, establish objectives, what needs to be done. And this is a bit site specific as well, like what will happen in Delhi may not happen in Kochi, Kerala, because the weather pattern is different, rainfall pattern is different. So you have to see what can really happen, what can really be done, and then with that you can identify the potential component, whether we should go for waste to energy plant, whether we go for anaerobic digestion plan. Then you compare your option, develop the plan, implement the plan, evaluate the plan, and then the cycle continues. Usually if you look at any good waste management system, they have a plan for 25-30 years, and then every 5 years they revisit the plan. And then in this, your education, public participation, and outreach is very, very important. And you can use this tool of LCA to make the decision making, especially when you're trying to compare the options. LCA helps you to find out which one has better environmental footprint. We have done a lot of LCA work on waste management infrastructure and different types of LCA over last 6-7 years. So that's another area which I think the MBA folks should be aware of, that what is so I just wanted to introduce you a little bit on that. It's basically try to do an environmental accounting exercise where you try to find out what is the real environmental footprint so that you can compare different options. So product A versus product B. If product A, different processes, which process has lower environmental footprint. So those things can be done using LCA. So once you have good idea of the waste, once you look at the different options, there are a variety of technologies out there. So you need to identify the best treatment technology which will work for you, because all these technologies working somewhere in the world. So technology is not an issue. Issue is the proper implementation of the technology on the ground. So whether you should go for biochemical conversion, depending on your waste, or thermal conversion, and the different technologies are out there, different products are produced, and you have to make sure that there is a market for these products. If the market is not there for this product, the plant will not be like self-sustainable. It cannot last, or it has to be economically viable project as well. And you need to be careful too whenever you implement. For example, see waste to energy in India. We have around 70 megawatt operational, under construction is 84 megawatt, proposed is close to 400 megawatt, 383 megawatts, but there is 66 megawatt non-functional. So we have to reevaluate that. Are we really doing waste to energy properly in India? Why it is non-functional? What really went wrong? Are we repeating the same mistake in this proposed as well? Should we change? Do we need to have a course correction? So those type of critical thinking is very, very important. We cannot just go on building plants and then again maybe this bar will keep on increasing. That's a wastage of resource. That's a wastage of taxpayers' money. So just after giving you a brief overview, I'll just take another 5 minutes. I think we are almost getting closer to the time. So I'm trying to like this. Just very briefly, I'll introduce you to a newer concept of managing waste in terms of resource recovery with a circular economy approach. This hydrothermal carbonization is a technique which is also referred to as wet torrefaction. We can convert the wet waste feedstock to high carbon rich product. We can make newer product from the waste. Say, just to excite you a little bit, say, for example, the food waste. If you wasted some food in a restaurant or your home, if you think about that, food waste can be part of your mobile phone in few months to a year from now. So we can produce carbon material which could be used in the battery of the mobile phone. So that's what I'm talking about. So that kind of technology that we are trying to work on, where we take the wet waste, do the hydrothermal carbonization, produce this hydrochar, and that. So what we have done, say we have taken the yard waste and food waste, we have done some pre-treatment, especially for yard waste because it has high lignin, to break down the lignin, then produced gas, which could be used as an energy source. Then the digested is gone through this hydrothermal carbonization. We made this hydrochar, and again, some pictures of those waste have been collected. This is how the experiment was set up for the biogas production. And this is a different temperature, different timeline. We looked at separated our liquid fraction with the solid fraction. So that's your hydrochar, and that's the liquid right there. And then when we look at the process, you can see for this is any process requires an input energy and an output energy, isn't it? So input energy is the yellow, which is the negative because you are spending that energy. Output is in the green, which is on the upper side, and the net will be output minus input. So you can see in all those cases we are getting net energy gain is there. So it doesn't mean that the conservation of energy is not valid, isn't it? Conservation of energy is valid. It is getting just converted from non-usable form to the usable form. That's it. So And then we looked at the characterization of the material that is made in terms of how good it is for the fuel material and all that. What is the heating value? What is the energy yield and all? And we found that it was similar to certain types of coal. So we can make fuel out of these food waste and yard waste, those vegetative waste, and that fuel can replace coal. Recently, we had that coal issue, isn't it? Just 10 days ago, that a lot of media attention on coal, that the coal is not being supplied. So why don't we take food waste, yard waste, which is produced throughout the country, use this technology, which shows potential in a lab scale, and then convert that to fuel and replace coal as much as possible, because coal is again a fossil fuel. So we can this is more of a renewable in nature. So it's we found that it's a more thermally stable compared to we were using a pre-treated, untreated, and all that could produce a good amount of gas as well. So more carbon content. Overall, it's line of circular economy, resource recovery, organic fraction of municipal solid waste using anaerobic digestion coupled with hydrothermal carbonization presents as a unique new opportunity. So that's what, so this was the reactor we used. So this is your hydrochar, that's a fuel pellets, and I already told you. And when you make those fuel, you have to pelletize it. So you have to make it a small pellets like this. So that was also done. This pelletizer was designed in our lab itself, and we got it fabricated. And we are looking at the big picture in terms of economic, social benefit, and market for it, because you have to have a holistic approach, isn't it? So you cannot have, so like where it can be used, how much can be produced, what kind of pre-processing it will be required, what kind of R&D opportunity is there, what kind of pelletizers there will be required, how the market will be, and what could be its, so techno-economic evaluation, that's very, very important, and using the social aspect into consideration as well. So we can use it as fuel, we can use it substitute for carbon black, activated carbon, you can use an adsorbent energy storage material, soil amender. So variety of uses there in terms of that. And that could be a solution to this agricultural waste burning, which is going to start or may have already started in say Haryana, Western Uttar Pradesh and Delhi area, and those areas creates a lot of air pollution. So if we can have this technology adopted there, we can produce some value-added products, and that value-added product can be used as well. So this got, we published some papers on it, got a lot of media attention. You may have seen that it was on media, kind of all over media for quite some time. And we also got some interest from some of the entrepreneurs to take it forward, but then the COVID came and then everything is a standstill since then. Then we are working on several other aspects. You saw electrochemical oxidation details from Josiji just before. So we are doing some work on that with landfill leachate, organic waste to biogas, using a sustainable, how to make the campuses much sustainable, nanoparticles for remediation, fuel from plastic biomass, and the smart waste, smart sustainability waste management for the cities. This is the overall work that we are doing right now, looking at different organic fraction of waste, try to have a lot of value added product. I'll not go in detail. Those of you are interested can contact me. So this is, if you want, some of you want to do PhD or something in this area, you can always contact us. So we are trying to do a lot of resource recovery, circular economy approach, and reduce the land waste going into those dump sites. Recently, we did some work with COVID waste, how to manage the COVID waste properly, what can happen, both municipal solid waste as well as plastic waste, and then also how this circular economy approach in waste management that I was talking about right now, how that will help in terms of UN Sustainable Development Goal, and what needs to change because of COVID now. So this is the recent paper, actually just came out a couple of weeks ago. So this is my last couple of last slides. So there are a lot of courses on NPTEL SWAYAM platform related to waste management, life cycle, circular economy. They have developed around 5 courses. So those of you who are interested to learn more about this, you are more than welcome. These courses are all available on YouTube for free. This is all funded by Ministry of Education. So, and from time to time, it is also offered in where you can take the weekly quiz, you can take the exam, get the certificate. So recently we did the course on plastic waste, we did a course on electronic waste, and in this coming January, just now we finished a course on waste management. In January, we will have a course on e-waste and then a general course on environmental science and engineering. And then we work with several universities around the world and we collaborate internationally with many universities. So I think, thank you for your attention. I may have taken a few minutes extra, but that's if you have any question, I'll be more than happy to answer.
Thank you so much, sir, for sharing this informative session with the participants. And I believe if any one of you and the participants, they wish to connect with Professor Dubey, please do that. So I again take this opportunity to thank all the eminent speakers. Thank you, Professor Dubey. I believe you are in US right now, yet you took out the precious time to connect with us. Thank you so much, sir. And definitely I agree with you that we need a holistic approach. If we definitely want livable cities, and without the effective implementation, it won't work for us. So to conserve the mother nature, definitely we need this proactive approach in spite of going for reactive. So thank you so much, sir, once again for connecting with us. So now I wish to go along with the vote of thanks.
Thanks a lot, sir, Professor Dubey.
Thank you,
For
sir. So what's the
giving
time
your
in US right now?
valuable time from US, and I guess it is midnight at US.
Early morning, actually.
Early
It's,
morning.
Early
around
morning.
Yes.
6 o'clock, 6:20. Yeah.
It's
Okay.
6:20 in the morning, sir.
Okay. Okay.
Okay.
Okay. Thank you, sir. Thank you. Thanks a lot.
Thank you. Yeah.
Thank you, sir. So in the end, on behalf of the Indian Institute of Management, Sirmaur, I would like to take this opportunity to thank all the esteemed panelists and participants of this national seminar on Act Responsible, Think Sustainable. First of all, on behalf of the seminar organizing committee, I wish to thank the respectable director, IIM Sirmaur, Professor Neelu Rohmitra, for giving us this opportunity to conduct this national seminar and for offering her visionary plans on sustainability for the Center of Sustainability and Environmental Management, IIM Sirmaur. Next, I also wish to thank the esteemed panelists who accepted our invitation for being a part of this seminar. Also, I wish to thank all the faculty members, IIM Sirmaur, for joining with us today. Also, I wish to thank Rizwanji, System Analyst, IIM Sirmaur, for offering the technical support to conduct the seminar smoothly. And last but not the least, I wish to take this privilege to thank all the participants of the seminar who have taken out their precious time and connected with us for this national seminar, Act Responsible, Think Sustainable. So with this, we end this seminar, and thank you once again for connecting with us today for this crucial occasion of Sustainability Day. Thank you, everyone.
Thanks a lot, everyone. Thanks a lot, Professor Pradul, for giving vote of thanks. Thanks. I'm ending up this session. Hope to be connected in future as well.
Thank you, ma'am.